Good morning, good afternoon, and good evening wherever you are, and welcome to the 2025 Virtual National Workzone Management Conference, sponsored in part by the National Workzone Safety Information Clearinghouse. My name is Matt. I'm with ARTBA staff, and I'm here to act as your MC today as we begin this incredible three-day event. So a couple of quick housekeeping notes before I introduce our introducers. First and foremost, I want you to take a look at your interface here and notice that there are a couple of options you may or may not be familiar with. One, of course, is the chat. Why don't we open up now? You'll see there is a chat window. So if you look at the top of your Microsoft Teams tray, you'll see a chat option. The chat is a great place to just talk amongst yourselves, share thoughts, and also ask technical questions. Not seen right now is Justin Russell, ARTBA's IT manager for this event, and Justin will help you individually with any technical questions you may have over the course of this process. You'll also note that only a few of us are able to be visible and heard. Those of us in the spotlight are presenters and moderators and whatnot. The rest of you, however, do have an opportunity to participate interactively. There is another tray you can click on called Q&A. Let's click on that now. And in the Q&A, you'll see that you can start a discussion for any of our presenters. Our moderators will take care of reviewing those and making sure that you are seen and heard. So that is my message to you. And so now I'd like to go ahead and bring onto our stage Mr. Brad Sant, who's our VP of Safety Programs and more here at ARTBA, who will take over and begin this first session, our welcome remarks. I'll see you all in about 20 minutes.
Well, good afternoon, everyone. I am Brad Sant, the Senior Vice President of Safety and Education at the American Road and Transportation Builders Association. I have been involved with the Workzone Clearinghouse for 27 of its 28 years, so it is great to be here and be with you this afternoon. Let me tell you a little bit about how we will proceed today. We'll begin today with an opening remarks by Cecil Brown of Valtier, who I'll introduce in just a moment. Following him, it'll be my pleasure to talk to you for a few minutes about the Clearinghouse, its history and what its purpose is, for those of you who may not be familiar with the Clearinghouse. Following my remarks, we will switch to our first session at 1 o'clock on smart work zones and queue warning systems. That'll be followed at 2 o'clock by a session on WZDx and data exchange programs that are happening and how that is affecting our industry. That'll be followed at 3 o'clock by a session on safety and commercial motor vehicles. And then we will wrap up our presentations of the day with a session on speed safety cameras in work zones. At the end of each day, we invite you to stay tuned. There'll be a series of videos shown at the end of each day on different technologies. And that's part of the ARTBA Technology Showcase. Different technologies that are being introduced to improve work zone safety. And also, as you noted at the beginning of each session, you will see a QR code. What that QR code will do is, if you click on that, that will take you to a section of the Workzone Clearinghouse where you will be able to find additional information on the topic that's being presented. So it's kind of meant to coincide with whatever topic is being presented. That QR code will then link you to a corresponding section of the website. So I invite you to take care of that. And I think there'll be also links in the chat if you don't happen to have don't happen to like QR codes. And again, just remind you that the National Workzone Safety Information Clearinghouse is a project that is sponsored by the U.S. Federal Highway Administration through contract with the American Road and Transportation Builders Association and the Texas A&M Transportation Institute. So welcome, and to kick us off today, we're going to hear from Cecil Brown. And Cecil is the Vice President of Business Development at Valtier, who is a leading manufacturer of roadside and workzone safety devices, including crash cushions, truck-mounted attenuators, and temporary steel barriers. He's worked in the road safety industry for more than 15 years with a focus on sales, business development, and building strong industry relationships. Cecil's been active in several industry organizations. He has long participated in ARTBA's Traffic Safety Industry Division and was just elected weeks ago as that division president. He's also been active in the American Traffic Safety Services Association, we all know that as ATSA, serving in leadership roles at the chapter, committee, and board levels. In addition, he contributes to Task Force 13, TRB standing committees, and other technical groups dedicated to improving safety standards and practices. Cecil lives in Columbus, Ohio, is the father of two, and graduate of The Ohio University, not to be confused with the other Ohio State school. So welcome, Cecil, and why don't you kick us off?
Okay, thank you, Brad, for that introduction, and good afternoon or morning to all of you. It's truly my honor and pleasure to be with you here today. The safety and sound management of roadway construction zones and the people who work in them and travel them every day are critically important to everyone participating in this conference. I've worked in the work zone safety industry for 15 years. The primary focus of the organizations that I've had the pleasure to be a part of has been the same: to make our roads safer so that everyone who travels them and works on them can get home safely to their families at the end of each day. Safety has also been a key cornerstone of ARTBA's mission and advocacy agenda since its founding. ARTBA and FHWA held the first joint national conference on highway work zone safety over 40 years ago. They've hosted many more since that time, including international versions at industry trade shows and in more recent years in virtual settings like this one. The networking opportunities, content sessions, sharing of best practices, and product demonstrations have been critical ingredients to the success of these events. This year's conference, which is hosted by the National Workzone Safety Information Clearinghouse, was organized by ARTBA in partnership with FHWA and the Texas A&M Transportation Institute. For those of you who don't know, ARTBA, FHWA, and TTI formed a successful public-private academic partnership in launching the clearinghouse 28 years ago. Today, the facility is one of the world's premier organizations offering a vast library of work zone management and safety resources, all at no cost to its users. The clearinghouse is bolstered by a new website that you can access at an easy-to-remember address: workzonesafety.org. The timing of this conference really couldn't be any better, and the actions that we take because of this gathering can help improve roadway work zones across the country. We are working towards legislation that will follow the landmark Infrastructure Investment and Jobs Act. Resources from the IIJA are currently flowing to transportation improvements across the nation. Throughout the first 4 years of IIJA, $240 billion have been made available to the states in formula funds to support a variety of different highway and bridge projects. The result of this important federal infrastructure commitment is leading to improved mobility and safety and more efficient movement of goods, which benefit the economy and the American people. In the process, however, more investment means a significant increase in the number of roadway and bridge construction zones. And in turn, that means greater risk exposure for workers and motorists. Over the next 3 days, the industry's top transportation safety experts will discuss best practices designed to make project sites safer and more efficient. So you're in the right place. There is one additional key aspect of the infrastructure law that merits discussion and your attention. And that's the provision designed to protect people who are most at risk when using our roads. These vulnerable road users, or VRUs as they are sometimes called, include people with disabilities, pedestrians, cyclists, and those in communities with inadequate infrastructure. Work is now underway to create programs and construct safety enhancements to better protect this group. But for those of us attending this conference, it is important to understand and advocate on behalf of another group of VRUs who also must be protected: roadway construction workers. As many as 200 of these fathers, mothers, children, sisters, and brothers are killed every year just by going to work. The people who make the promises of the infrastructure law a reality are not discretionary system users. They are required by their jobs to work feet from traffic that can be moving 65 miles per hour or higher. It is the collective responsibility of both the private sector and public agencies at all levels of government to advance the provisions of the current and future infrastructure laws that protect all VRUs, especially construction workers. However, we must continue to advocate on their behalf because a great deal of the public outreach and implementation efforts to date have not been focused on them. In fact, they are the forgotten users, and we all must do better. Let's take the opportunity we've been given with the development of a new infrastructure law to not only make significant improvements to our transportation infrastructure, but also to improve the safety and lives of our most important resources, our industry's workers, our industry's people, many of whom are participating in this conference. Again, we are grateful to each of you participating in the conference. You're making a difference in the mobility, the safety, and well-being of all transportation system users. Thank you. And Brad, I'll now turn the program back over to you.
Thanks so much, Cecil. We appreciate you being here and for your leadership in the industry. I would now like to share a few slides that talk a little bit more about the mission and the activities of the National Workzone Safety Information Clearinghouse. Those of you who are familiar with it, and maybe a few of you who are not. And so the clearinghouse has long been a great resource for folks who are using the system, and it's been around for a long time. As this slide shows, some of the past logos from the past 28 years that have been used to market and to promote the clearinghouse. But as Cecil mentioned, this is a 28-year partnership between FHWA, ARPA, and Texas A&M. And we appreciate the many years of dedication that all these organizations have put, but most importantly, you, the users of the clearinghouse, who make this all possible. So let me tell you just a little bit about what the clearinghouse does offer. So as many of you know, because of the website, this is one of the largest online resources for public and private information about roadway workzone management and safety, and it's found at workzonesafety.org. Hope you have that bookmarked. We offer custom research. This annual Workzone Management Conference, there are quarterly webinars, podcasts. We send out brochures and pamphlets and posters. We partner with others on National Workzone Awareness Week, and it's the clearinghouse who actually sends you the posters for National Workzone Awareness Week. So there are a lot of things that the clearinghouse does. Sometimes that's noted, sometimes not. Now, as often noted, one of the main features of the clearinghouse is the website. And I want to just go over a couple of the features of that with you here today. So as you see at the top of the screen, there is a lot of ways to navigate it and to find information. You can put up in just a search bar and type in keywords, and it'll bring a lot of things that are related up there. But also across the top, there are a number of drop-down menus that provide a lot of really good information. So let's talk about a couple of those and how those work. So for example, if you go over to the left-hand side and you see the Workzone data, you'll drop that down. It'll bring you a menu of different items that are in our database for all different types of data on Workzone safety. Now, we'll have a presentation on that tomorrow at this time, so hopefully you'll be able to join us for that. But I just want to make you aware that this is probably one of the most important features that we have in the clearinghouse. But also of note is any of these graphs that are here, if you click on them, they will pop up in a large size. You can right click and copy those graphs, and then you can use them in your presentations and for information. This is public domain information. We do like you to cite where it comes from, but all this data and information on the clearinghouse is there. It's made very usable for you, and those charts are specifically designed that you can take them, copy them, and use them. Another great feature is when you're trying to find information, maybe this like topics of interest. So those are general topics that will pop up when you are looking for certain types of information and to get it to you really fast. And the nice thing about the things on those menus is each of those drop downs takes you to a page with very specific information, but it's not just one piece. There's sometimes many levels of information within those drop downs. So for example, on this one, on smart work zones, if you look down there at the bottom of this pop-up here, you'll see a gray area where there's a lot more information where you can just click the plus sign and that drops down. And again, just because this is a screenshot, there's a lot more areas in that gray part that you can expand upon and find a lot more information. So in each of those drop-down menus like topic of interest, you can find more information on anything you're looking for, and I should say anything, but key things that people might look for. and find that information very easily. Now, throughout the day and throughout the conference, others will speak and talk about specific portions, perhaps of the website, that relate to the session that's being taught. But we hope that you have a little bit better understanding of the National Workzone Safety Information Clearinghouse, a lot of the resources that are available. All this is done at no cost, and to take advantage of it and to use it, because there's a lot of great information that I think we can use to save lives. The other side of that is if you have developed information or you're aware of something new that's come out and you think it should be on the clearinghouse, you can send us a note and make us aware of that so that we can add that to our databases and to our information. So that is just a very quick highlight of the clearinghouse. And if you have any questions or anything, feel free to pop them into the chat and we'll talk a little bit more about them. In the meantime, we've got the conference going and we will resume with our next session at 1 o'clock. And in the meantime, we'll keep this chat open, the Q&A open. If you have any questions, keep talking and we'll be back with you shortly. All right. Thank you so much for being with us. While we are waiting for the next session to begin at 1 o'clock, I just wanted to make a note that a lot of folks, the Federal Highway Administration, OSHA, and other agencies spent quite a bit of time preparing and assisting in getting the conference ready to go. Unfortunately, due to the government shutdown, they are unable to participate with us, but I do want to acknowledge the work of folks like Martha Kapitanoff, Jawad Parancha, and others at Federal Highway who have spent many, many hours working on this conference. And unfortunately, though they had planned to be here and to participate, are not able to at this time. So if you see them or know them, be sure and pass along that gratitude for the much work and hours that they put into preparing this, even though for reasons beyond their control, they're unable to participate today. So again, thank you, and I want to make that acknowledgement.
And ladies and gentlemen, just a reminder, we'll be back at the top of the hour, right at 1 o'clock, with our next session, Smart Work Zones, Cue Warning Systems. And each session begins at the top of each hour, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and so on. So we'll see you here in just 10 minutes. And ladies and gentlemen, we're just 5 minutes out from our next session, the Smart Work Zone's Q warning systems. Going to be a very exciting session. Our moderator will be Melanie Laird, and we have someone from Iowa State University, Skylar Knickerbocker, as well as Bob Berdia from TTI and Michael Boland from TxDOT. So very excited. We'll see you in just 5 minutes. Coming up in just 3 minutes, Smart Work Zones, Q warning systems. We'll see you in just 3 minutes. And welcome back. We'll start now with our 1 o'clock session, Smart Work Zones, Cue Warning Systems. So I'd like to welcome onto the stage our moderator representing ARTBA, Melanie Laird.
Good afternoon, everybody. Welcome to the 1 o'clock session. I have the pleasure of introducing our three speakers for this session. And just a quick reminder, please feel free to use that chat if you have any questions during the presentation. We will have some time at the end to get to those. So as it's going, feel free to drop your questions in there. We're looking forward to it.
Quick correction, Melanie. The Q&A is for our questions. Chat will be for anything, just conversation. But if they have a question for you, make sure it's the Q&A. Thanks.
Awesome. Well, I have the pleasure of introducing our three speakers today. I'll start off with Mr. Bob Bridia from TTI. Mr. Bridia is a dynamic and innovative transportation professional with 35 years experience in all aspects of operations, technology, and project management. He holds the position of Senior Research Scientist. He also leads the System Operations and Technologies Division and is a developer and implementer of leading-edge systems and deployments, multiple states, projects, and sponsors. He's received his Master's of Science degree in Civil Engineering from the Pennsylvania State University in 1991 and is a PMI project management professional. He has been with the Texas A&M Transportation Institute since 1996. Welcome, Bob. Our next speaker, I have Michael Bolin from Texas DOT. Michael Bolin is the Deputy District Engineer for the Waco Task District of TxDOT, which includes 8 urban and rural counties in Central Texas. He received a bachelor's degree in civil engineering from Montana State University and has a master's degree in civil engineering from the Texas A&M University. He has served as research project champion and advisor for several research projects, including improving the use and effectiveness of smart work zone deployment. Michael has served as an advisor on the safety committee for the development of TxDOT's 5-year strategic plan, as well as an advisor for TxDOT's efforts to implement a comprehensive artificial intelligence plan. He currently serves as the project manager for work being performed by Texas A&M Transportation Institute, along with the I-35 corridor related to mobility, travel information, and the implementation of innovative technologies. Uncle Michael. And last but not least, we have Skylar Knickerbocker with the University of Iowa. Mr. Skylar Knickerbocker is a research engineer at Iowa State University, working primarily in areas of traffic operations, maintenance, and safety, including safety data analytics, data visualization, and big data management. So welcome, everybody. I'm looking forward to your presentation, and I believe I will be passing it off to you, Bob.
Great. Thank you so much, Melanie. I'm going to go ahead and share my screen, and we'll get started. Let me put this into presentation mode quickly here. All right. So I want to talk today for usually I make a joke and saying I'm going to talk for about 2 hours, and then everybody gives a nervous laugh. But about 15 minutes or so on hybrid travel time and the queue warning system. This is a system that was developed for the Odessa district of TxDOT and is online at Interstate 20. So we've all been stuck in this type of situation where there's nothing but a sea of red lights ahead of us, and we have no information about what's going on, how long it's going to last, or anything else. We in the profession obviously have recognize those types of situations and develop travel time systems where we try to give near real-time information to destinations using a variety of different data sources. There's different data channels or output channels that we can use. Typically we try to provide information on segments that are approximately 2 miles in length, 1 to 3. The challenge of all of this has always been do I pay for sensors and upkeep on the road, or do I do the operational expense of probe data? And there's many other different types of considerations related to solar power and those types of things. Likewise, end-of-queue warning systems have a safety benefit. The real purpose is to reduce the rear end crashes and heartbreaking crashes by giving people information and notifications ahead of actually coming into those situations on the roadway. Very similar types of things here in terms of data sources and design choices and those sorts of things. So I won't belabor the point by rereading all of those slides. But the challenges that we see are really, our travel time segment, length, and placement, understanding destination choices. For example, in the Odessa district on I-20, we originally started out signing to the next exit, but that really wasn't. It didn't really provide enough decision site distance to make decisions, so we started a leapfrogging approach. The other thing that is really interesting about the how some folks do full lane reconstruction on freeways is the lane drop dependency. So in some cases, in some districts in TxDOT, they will reconstruct the freeway by routing everybody to the frontage road and then shutting down the main lanes. That's great from a traffic perspective and continuity of flow and all of those types of things. But it's very challenging for end of queue warning system because there's no taper anymore. So there's no known start point for where to put the equipment. And end of queue systems also, there's different back office models from different vendors. Some sell essentially a package of software and sensors and say that folks should, the construction contractors will be responsible for doing things. Others sell a complete back office solution for things. So they all also have some shared challenges on, balancing speed and stability in the data. The biggest one is traveler trust is easily broken and hard to regain. If you tell somebody the wrong information and it's wrong a couple times, they're really not going to believe it anymore. So what do we do about this? Well, we constructed a hybrid system that does both travel time and end of queue warning. The nice part is that one deployment can do both, and the infrastructure that's in place can do both. What we did is we equipped the entire 40-mile corridor between Odessa and Midland on I-20 with PCMS approximately 5 miles apart, so 8 in one direction, 8 in the other direction, and that's essentially a permanent during the time of construction, which is somewhere around 10 years. So that'll be a permanent installation along that whole pathway, giving traveler information to folks. The same data feed that we're using, which is third-party data, can detect both, can do both the travel time with algorithms as well as detect the slowdowns. And that way you have one overall system that you're trying to utilize and trying to maintain, and it serves both safety and mobility purposes. So let's just look for a little bit about how it works. In a normal situation where traffic is flowing along just fine, you can see on the roadway here that there's different travel segments. Again, those can be anywhere, whatever distance they are. Since we're using third-party data, from INRIX, we're using their XD segments, so typically those are anywhere from half a mile to a quarter mile to a half mile in length. And you can see from the level of traffic here in the illustration that it's not very congested at all. So our sign here is simply going to sign to a destination and tell you the miles and the time to get there. Standard travel time type of system. This is just an illustration, courtesy of AI. Maybe a few more cars than you would actually expect for 18 miles, 16 minutes, but nonetheless. Then we go into how the queue warning works. So what we're talking about here is there are certain segments here inside the overall corridor that are starting to get congested. They start up here on the right-hand side and progress down through. So what we're really trying to do here is understand where the back of the queue is, and we're using that based on the metrics up above here of speed. So this segment here, according to this installation, would be 45 miles an hour. In here, it's slowing, so it's going to be between 25 and 45, and then down here again, it's free flow because they haven't gone up to where the traffic is slowing yet. So what we do is we use this PCMS that's on the road, and we sign to slow traffic X miles. So again, a fairly standard implementation in terms of messaging. Then the algorithm needs to be robust enough so that it handles a slowdown here, no slowdown here, another slowdown here. In that particular case, the back of the queue doesn't really change at all. So we don't change the messaging when we see different segments of roadways doing different things here. What we're trying to do is give an overall presentation of the traffic along the corridor. So this is just what it would look like here, just doing some illustrations to try to bring some realism into the pictures that are on the screen in terms of depicting the traffic. So this is just slow traffic 1 mile. Then when it gets to the fact that the traffic is actually below 25 miles per hour, which is really where it gets into your stop and go type of system, that's when we change the messaging to stop traffic. Again, same type of situation. We have sorry, my mouse was getting a little overacted there. We have the situation here where we have the back of the queue, we have segments that are going along and are showcasing some congestion. So based on the data, we change the messaging to stop traffic X miles. Same thing that we're doing there. Now, the innovation of this is really twofold. One is it combines both systems. So it combines both travel time and the queue warning. The other innovation of this is that we've implemented a traffic clears type of message. So for any of us that have been sitting in traffic before and you've been in an end of queue warning system and it says, traffic stopped 3 miles and you're right in the middle of the traffic, you're kind of looking at the sign going, well, duh, I already know that, I'm already here. So once drivers are in the queue, we change this message here to traffic clears. Now, that's a little bit of a human factors type of thing where we're trying to get, trying to prevent a little bit of the road rage or the anxiety of what's going on with drivers on the road, helping to try to keep them a little bit calmer. Typically people say that if they know how long it's going to take them to get through a particular segment, they can deal with it much better. A number of surveys have proven that in different districts across Texas and in other places across the nation. So what we do here is we have the stop traffic alerting to the back of the queue, and then once the queue backs backs forward past the additional sign, we sign to the front of the queue and say, that's when traffic is going to clear. So here we can do the same type of thing. This is just a multiple traffic clears type of situation. Again, here, even though this one segment here is uncongested for whatever reason, we're not going to sign this one, the one on the left to just segments 7 and 8 and say it's clear and then throw you right back into congestion. We're going to sign it to the front of the queue all the way at the junction between segment 2 and segment 1. And just an illustration of a sign on the side of the road. We also have information where we're putting all of this onto a website. You can see there in the purple segment in the middle, that's where the road is closed on the main lanes and all the traffic is on the frontage roads, and you can see the different signs that are present there. We are also doing metrics for keeping the data on every activation, every message of every sign every 5 minutes, which is the update cycle. And looking at some of these things, this is an overall view across several months, but looking at this, obviously you can tell some things that are going on. For example, look over here on August 5th and August 6th, there were a lot of activations in slow traffic and stop traffic. So obviously something different happened that day. You can go back and you can look at whether that was an incident or whether there was significant construction or perhaps a weather event or anything like that. We're also taking this information and putting it out to DriveWise so that it can get into the heavy vehicles, trying to get a more holistic spread of this type of information and how we can do that. So overall, why are we doing this? Well, hybrid allows you to do automatic switching, allows you to implement the entire corridor, set up the algorithm, and then essentially just let it run. Other than doing periodic maintenance on the signs that are on the roadway and responding, of course, if they get hit or anything like that, this is pretty much a set it up and leave it and go about your business elsewhere type of system. One deployment supports both the travel time and the queue warnings, so they get both predictive times of arrival and the immediate safety warning. So you get both safety and mobility benefits under one investment. That's really the overall key of why do a hybrid system. And with that, I'll turn it back over to Melanie, and you can tell me if we're doing questions now or later.
Perfect. Thank you so much, Bob. I think we're going to hold questions until the end. So if Michael, you'd like to go next, we'd love to hear from you.
Sure thing. Make sure, Melanie, let me know if you can hear me okay.
Yes, we can.
And you should be seeing my screen.
We are good.
Perfect. Okay, so I feel like I could have added a little bit of liveliness and humor to this whole presentation if you would have let me introduce Bob instead. I have a few things I could say about him. For those of you that don't know, Bob and I have worked together a lot over the past decade, I believe, especially on the I-35 corridor here in Texas. So I'll be presenting QBot, which is the end-of-queue autonomous warning system, which is sort of the next progression to the system he was talking about in his presentation. At the end of the day, I won't go over everything Bob just said, but TxDOT really has led the charge in smart work zones across the country with a specific focus on end-of-queue warning systems. We have done a lot of work, especially on the I-35 corridor over the last several decades. We have developed guidance documents, we've developed standards, we've developed decision matrices during the design phase on when and how to use end-of-queue warning systems in our projects. And as he pointed out, traditionally the old school systems used traffic sensors mounted along the roadway to collect data for us. When the end-of-queue warning systems made the transition from a agency like the Texas A&M Transportation Institute to low bid systems with contractors, there was a bit of an issue there. When you put all your focus on a research project or an implementation project, you can really do it justice. But we have to put it in the real world, and we have to have real world applications, and it has to work reliably for us. Bob mentioned we don't want drivers to start ignoring the message because it's not working correctly. So we implemented a research project called Improving Smart Work Zone Deployments in Texas, where we reviewed some of the deployments under the design bid build system of going out to transportation contractors. It analyzed everything that was going on, and at the end of the day, it definitely did say that it was hit and miss as far as success when we implemented them through that process. This is an example of what Bob already showed, but he basically pointed that there's a lot of complexity to this. And at the end of the day, when you think about it, traditionally, traffic control on our construction projects, it's been a struggle to get signs, static, old school signs on the right-of-way to be maintained, moved, put up properly, all of that. And now we're adding a technology component of it and a little bit of a design component to it, and you can imagine where the hurdles are and the stumbling blocks are. That all being said, we have found on the I-35 corridor, and this is specifically between your Austin, San Antonio area and your Dallas and Fort Worth area. Basically the span, the non-metro span between those areas. We did find that during research that it reduced end of queue crashes significantly, and therefore saved in cost, saved in lives, saved in injuries. So the proof of the value of these systems was there, and we felt at TxDOT, especially in the Waco district, a sense of urgency to get these things up and running as fast as we could and to be utilized appropriately, because again, if they're not implemented effectively, we don't see the value, and we absolutely want to see the value of these different systems. So, technical side of things, right? He gets to analyze everything and really roll up his sleeves and dig into it. I have the easy part. I came to him saying, I want a system where I basically just grunt and point and say, want sign here. And it should happen. Easier said than done, right? I gave him a little bit more information than that. We talked about wanting it to be fully autonomous, user verification included, so that we are not fully relying on the system to make decisions for us. We wanted rapid deployment, and we wanted it to be versatile and easy to use. So we did focus on the I-35 corridor. We used an existing traffic data to analyze historic queue formations along the corridor, since we had been collecting that data for over a decade, and this really helped us understand maximum queues expected on any given segment along the corridor. We did switch from sensors to INRIX data. TxDOT has that subscription to have that INRIX data, which makes this all work seamlessly. And then we created a deployment dashboard, again, with the focus on ease of use of this system. It's based on a Wenco PCMS. We did put an upgraded 360 camera on it, in part due to the verification requirement, and with two-way communication ability to basically communicate remotely and to do any processing, not edge computing, but central processing, as far as any kind of algorithms go related to this system. So that's kind of just the high-level basic setup of what we're looking for. Obviously, being a PCMS that you see everywhere out there, they are highly portable and easy to use. So this is what's really, really neat about this whole process. While we were still working out the technical parts of the hardware and getting these units sort of built and up and running, we could virtually deploy these things in the field. And there's an example here on the screen which shows this board thinks it has been deployed just south of Belton, and it thinks it's doing a really good job reporting stop traffic 3 miles from a traffic queue that we're seeing northward of that position. And it's doing a wonderful job, and it's doing a really great job. And in reality, it is actually sitting in some parking lot in Bryan, Texas. And so, gotta worry a little bit about the risk factor that, when these things become sentient, we're going to have a bit of a problem with our robot overlords. It's going to remember how we treated it. And so we do have to watch ourselves as far as that goes. But that being said, we did get these things deployed. They are up and running in the Waco district. We have 3 of them. And we definitely have some lessons learned, nothing too major. Things that we don't think about until we really get these things out and use them. For one, they should be standardized. They should be compatible with devices being used by our crews out in the field. So at TxDOT, all our maintenance crews, we require a standard size trailer hitch on everything that we tow, so that decision doesn't have to be made by a various individual in the field. So we standardize those. You should have some familiarity with the traffic characteristic on the corridor you're deploying. If it's an FM road, you should be aware if it has adequate shoulders or not. If it's a larger road with shoulders, you need to have some idea about vertical and horizontal curvature so that you can make good decisions on where you place it as far as sight distance goes, and then understanding you want it upstream of the queue, so you should understand what max queues are. It's very, very important not to create more driver fatigue or to give them erroneous information. So again, in the virtual environment, It can be monitored to ensure it's not short cycling messages or just giving erroneous messaging. I was in Kentucky a couple weeks ago, and I actually saw the end of queue message boards, and I was excited about that going into one of their construction zones, but it said stop traffic 2 miles. And when you got 2 miles up the road, there wasn't even slow traffic, right? It was a static message. And I think that's what we're trying to warn against is these signs, if we want people to pay attention to them, have to be extremely accurate. And being a rural and semi-urban area, theft and vandalism concerns do exist, from taking electronic components to taking wheels off the rigs. You have to harden them as much as you reasonably can and not leave them deployed to any given length of time. And the example I'll give real quick is on this deployment here. This was an area that we considered for variable speed limits. It did not get picked by our traffic division. We did not deploy variable speed limits in the area. But what we did is we hauled 2 of these out, one on either side, and they are warning of the daily random queues that develop through this area during rush hours and other times. So they're quickly deployed, and they're filling a need that we weren't able to accomplish any other way. We have one in another county which sits in the maintenance yard, and it's used for a call out. That section tends to have big rigs that catch on fire, and whenever that happens, we know we're going to have a significant lane closure for 3+ hours. You can get one of these units out there and deployed in under 30 minutes, and you haul it out in the field, they turn it on, point in the right direction, and it's good to go. It calibrates itself. It starts talking to the traffic data stream. It knows what messages it's going to show based on algorithms, and it starts showing that message. When the queue clears, it will show a very boring message like drive safely or have a nice day, and that's it. And it can stay out there as long as necessary until the maintenance crews get around to hauling it back into the yard. So that's kind of how we're testing these things, and they've been working great out in the field. So what does the future hold for us? So this all stems from Waco being, like I said, a rural / semi-urban area. We understood that a lot of solutions are being developed for metro areas and that have full traffic management centers, full infrastructure build out, things like that. We don't have that. And there's a lot of areas across the country, honestly, which don't have that. And so forgive the pun, but we kind of wanted to jump the queue and come up with a solution that could be implemented really, really quickly, really, really fast with the minimal amount of effort. And that's basically what we've come up with. We are looking at deploying during other scenarios. During events. So if we know a university move-in date along the interstate and we know traffic queues are going to form, we can get these up and running ahead of the event. We're considering edge computing. We talked about right now it's all centrally located. If at the end of the day we deploy one of these in an area which doesn't have a dedicated communication stream, we still have to get traffic data, but we could look at doing some of that computing at the unit itself and not centrally. And then we're looking at things like, could it be used for flood monitoring? Using machine learning, image recognition, and the camera, could these be set out in places where normally we would put a maintenance worker out, basically closing a road until the water receded enough till we could open the road again? We could do that virtually with somebody, with the machine itself giving us a heads up, and then somebody sitting in a virtual environment looking through the camera feed and determining whether to change the message on the sign or not. Traffic incidents alerts, and then truck mounted signs. Here recently we've had some of our units, our light pickup trucks, deployed with full matrix displays on them. A little bit smaller, but still it's a possibility to be able to go and park on the shoulder and warn of upcoming queues. Those are the few things that we're looking for in the future. And then ultimately including these in any of our contracted traffic controls so that TxDOT's not the only one having to deploy these when necessary. That's the bulk of my presentation. I believe I'm right on schedule. If I have piqued your interest and you are interested in the system, I am a person to reach out to, along with Leonard Ruback from TTI as well. There's his contact information on the screen. You can reach out to him, and we can start having these conversations about how we get these things up and running elsewhere. And again, I believe we're deferring questions to the end, so that is my time. I will turn it back to you, Melanie.
Fantastic. Thank you so much, Michael. Really interesting, engaging presentation. I loved the robot. So we will, last but not least, hand it over to Skylar Knickerbocker. So feel free to kick it off. Oh, Skylar, you're on mute.
Sorry, can you hear me now, Melanie?
Yes, you're good to go.
Perfect, thanks. Thanks for having me. One correction I did want to make, as much as I love my friends over at the University of Iowa, I am with Iowa State University, go Cyclones. So today it's a great build up with what Michael and Bob presented, as I'm going to talk through some of the work that we've done in Iowa, and a couple different research projects that I'm compiling into this one presentation. One talking about the benefits of the Q warning systems that we've been able to quantify in Iowa, and then a future looking way of using Q warnings, using some new emerging data beyond even the probe data that Bob and Michael were talking about. And so with that, just a little bit of background. Iowa DOT's had a traffic critical project program back since 2013, where they deploy various different mitigation strategies to mitigate congestion or mobility issues in work zones that they feel are going to cause mobility or traffic issues, or they feel are traffic critical, hence the name. And so they've got a ton of different strategies, and we deploy anywhere from 34 to 45 work zones, or 34 to 45 work zones get identified as traffic critical. And as part of that, over the last 5 years, it's ranged from 9 to 17 work zones have had Q warning deployed as part of that. And our Q warning systems, like what Bob and Mike were talking about, are the traditional approach, where we have a statewide vendor that will deploy sensors along the roadway. All of that data gets integrated into our ATMS, so we don't pay a vendor to deploy the actual Q warning logic of it. But the sensors get integrated to the ATMS, and then the ATMS will post the slow or stop traffic ahead messages. So one of the challenges, or one of the questions the Iowa DOT face is they love this program and they don't want it to end, but they just want to be able to be prepared whenever somebody does ask. You're investing all this time and effort into the traffic critical project program. What are the benefits to it? And so as part of that, they wanted to develop some Iowa-specific crash modification factors to really show the benefit and the value of the TCP program. And that really started with evaluating the Q warning systems. That's, again, one of the main elements that get deployed as part of the traffic critical project program. And so with that, Iowa State evaluated the Q warning systems that were deployed from 2013 to 2023. So 10 years of Q warning systems that have been deployed, and comparing that to comparable non-Q warning systems, work zones. And we found that there was a 31.9% reduction in our fatal and major injury crashes whenever we had the Q warning system. So really just showing the benefits and the value of Q warning. And this was comparable to other research that had previously been done at TTI. But again, showing the value, and showing the value specifically in Iowa. There was around a 3% reduction in total crashes, but not nearly as significant as the reducing the fatal and major crashes that we're trying to prevent with these systems. And so then, again, I'm really just building off the challenges that Bob and Michael were talking about. This is just a map showing one of our IWZ, or traffic critical project program, work zones that we deployed this year that had Q warning. The orange dots represent where our sensors are located, and then you can see the signs that are shown on the map that would be posting the slow or stop messages. But the thing that we have is, what if a queue starts ahead of one of our signs? How are we going to get the message to the drivers in those situations? If you've worked with the contractors, there's not a whole lot of space a lot of times in the work zone to deploy sensors within the work zone. So a lot of times we're restricted to just providing those queue warnings leading up to the work zone and not able to actually alert of slowdowns within the work zone. And even when we do deploy the sensors near the taper, it's always in the way. The contractor's always calling you saying that we got to move that sensor, and there's just a lot of coordination in terms of moving the sensors around and going back to the kickoff presentation of trying to improve our worker safety. We just want to avoid getting those people out on the field. And then the last one is sometimes the sensor is in a good place, but they'll just change the lanes on us. And then that ends up generating a bunch of false alerts to the public because we're detecting construction traffic now as opposed to mainline traffic and generating alerts because they don't always tell us that there's changes to those lane configurations that we need to update the sensors. So just building off of the challenges that we have with the traditional queue warning systems that are relying on sensors. But now looking ahead, we've got new data sources. Bob and Michael talked about probe data as being a data source that we could use. But in addition to that, we have connected vehicle data now that we're able to get, and a lot of vehicles are basically dropping breadcrumbs every 3 seconds, showing their location and their speed as they're traversing our networks. In Iowa, we have around 700,000 data points that we're getting from these vehicles every single minute. That equates to around 12 million data points that we get per hour and 288 million data points per day. And this isn't connected vehicles that are requiring the short range communications or DSRCs or onboard units. These are vehicles that are out on the roadway today, typically 2018 and newer vehicles. And this is a map showing all the data points that we have for just a small area in Cedar Rapids, Iowa, where we're getting data points on every single roadway in this area. And whether it's a local road, the main line, interstates or state roadways, we're getting data in these vehicles' trajectories traveling across the network. So then if we relate it back to our work zone, now here's that same work zone that I was showing previously, and now I've overlaid all these purple data points, which are all the connected vehicles that we've had passing through this work zone. So we're getting, again, tons of data that are traversing this work zone, and then the question is how can we leverage that to provide queue warning messages to the motorists as they're traveling through our work zones. This is part of a SWSD, or the Smart Work Zone Deployment Initiative, which is a pool fund that supported this project that was looking at different data sources. And so in this graphic, you can see the blue line represents our traditional sensor, and it's detecting the queue and then triggering the slow message based on the dash line of 45 miles per hour, which was consistent with the previous presentations. We use INRIX as part of this study, but you can see there is more latency in the probe data that we use for detecting those slow messages using the probe data. But with the connected vehicle data, we were actually able to detect the slowdown quicker in this example here and be able to detect it. And the idea behind this is really with the connected vehicle data, we're able to look at the entire approach to the work zone as opposed to just the point detections that we have to rely on with the traditional sensors, or with the probe, we're at whatever segmentation they define with the probe data segments. And so looking up here at the top, on average, it was around 5 minutes faster that we were able to detect the slowdowns using the connected vehicle data as compared to the traditional sensors. So this was some really promising results for us in Iowa to have a system where we don't have to deploy or have workers out in the field to deploy the sensors, and being able to actually alert motorists quicker of a slower stop condition out on the roadway. The other thing that we explored as part of the study was, since we're having raw data from these vehicles, we're not simply limited to the average speed that's used in a lot of the other Q warning systems, whether it is from a sensor or from probe data. With the connected vehicle data, we can actually look at a whole host of different performance or speed metrics. So from median to the 85th percentile, minimum speeds or maximum speeds. And so as part of the SWSD project, we explored all those different types of metrics to try to figure out which ones would work best for a Q warning system. And the graphic here on the right is showing the percentage of missed calls and the percentage of false calls that each of the different metrics were having compared to the traditional system that's deployed out on the roadway. Then we took that SWSD project, since that's a pool fund, and for a lot of states, we tried to then take the great results that were shown from there and start to implement it in Iowa. And first step was just validating those results in Iowa and confirming with recent work zones that we were seeing the same thing. So again, we took a smaller list of performance metrics from the connected vehicle data and did the same thing, looking at the percentage of false calls as well as missed calls, and looking at the various different metrics that we wanted to evaluate as part of the system. And the chart on the left just shows just the total or the percentage of those that were having the missed calls, false calls, or true matches. So ideally, we wanted to choose metrics that had a whole lot of green, indicating that we weren't getting too many false calls or missed calls, and we were truly matching the slowdowns that were detected using the sensors. And then, in addition to that, latency was important to us. We wanted to be able to detect the slowdowns quicker, but we didn't want to detect them at the expense of not having or having too many false calls or missed calls. So in combination with the previous slide that I showed, we just looked at what the latency was. The two charts on the left are the onset latency, so the latency at the beginning of a slowdown, and then the two charts on the right are the recovery latency, or as the queue is clearing, how much longer are we leaving the message out on the sign or removing the message from the sign. And so you can see, regardless of which metric we chose, it was anywhere from 3 minutes to 7 minutes quicker in terms of detecting the slowdowns. And we did a few different factors of whether we were spatially filtering by because if we were focused on just around the sensor location, regardless of what distance we had, we were seeing similar results in terms of the latency from the connected vehicle data with the sensors. And then again, just trying to validate this with real results from an actual slowdown that we had in Iowa. You can see in the bottom image here, we had a crash that occurred, and you can start to see the traffic going all over the place. The map on the top left is showing some of those individual trajectories that we received from the vehicle, and you can see the color indicating the speed of the vehicle, with vehicles starting to slow down as they were approaching where that crash occurred. And then if we look at the actual speeds from the sensors and the connected vehicle data, again, it was around 5 or 6 minutes between when the connected vehicle started detecting those slow speeds from the vehicles compared to when even one of the lanes started detecting slow speeds from the sensor. So now getting into implementation, that's always the challenging part of these types of technologies, when we're taking these new and emerging data sources and trying to fit it into our traditional systems. And again, in Iowa, the ATMS is our system that posts the message on the DMS, so we really need to integrate it within that system. So this is just a high-level overview of our general workflow, because we ultimately needed to get this connected vehicle data into the ATMS, but the ATMS isn't set up to handle these hundreds of thousands of data points that we're getting every minute from the connected vehicle data. So in general, we collect the data every minute from the connected vehicles. We filter it based on the geofence, and then we filter it for only the last 10 minutes of data. And then we essentially treat the connected vehicle data as a virtual sensor so that we can integrate it into our ATMS system, which then after that, it handles the virtual sensor from the connected vehicle data, just like any other sensor within the ATMS. And to just visually show this, this is 1 minute of data that we got from connected vehicle data with the arrows indicating the heading of the vehicles. We filter it to an area like the orange line indicated here for that geofence area. The blue arrows are then the arrows that we filtered for only the vehicles that are heading towards the sign that would be posting the Q warning messages. And then again, we aggregate that data into a virtual system that our ATMS can consume to then post the messages on the DMS. And then I'm just going to, in the interest of time, skip through these slides, some of the background into our ATMS, and really just start getting into the current implementation. So right now we have 29 corridors, which corridors are basically a Q warning system deployed in Iowa, and those are across 8 different work zones that we have in the state. We have the connected vehicle data process running in parallel with the actual Q warning systems using the sensors, so we can compare the accuracy of the two systems. As of right now, the system was run active for around half a month in June and July, or in June, and then we got the system back up and running just about a month and a half ago in August, and it's been continuing to run, and we expect it to run throughout the rest of the 2025 construction season. Then just showing a few different results. At this point, we're less concerned with all the criteria and the background that goes into it, and really just focus on what's the end product result of messages being posted to the DMS. And this does show for the connected vehicle data when the slow message would have been posted and when the stop message would have posted. So we're seeing similarities between the sensors and the connected vehicle data. The added benefit is detecting posting the message on the DMS 6 minutes ahead of time and leaving that DMS on 6 additional minutes based on us seeing slowdowns. The bad part is we then also saw a lot more slow messages after the fact. So that's something that we're continuing to explore to trying to, again, not lose trust in the public and avoiding some of these false calls. And then here's just another example where we have sorry, I get the label wrong on the left side. The connected vehicle data is up top and the sensors on the bottom, but we were able to detect the slowdown 13 minutes ahead of time using the connected vehicle data, and it lasted 17 minutes more. But we do see a lot of back and forth in terms of the slow and stop messages that need to be confirmed and validated for the system. And then just one image from a slowdown that we had in the work zone from this last Sunday. You can see the slow vehicles detected here, and it's probably hard to see in the stream, but every vehicle that's passing by this camera, the brake lights are activating, and with the connected vehicle data, we were able to, it was activated for around 8 minutes from 2:14 on Sunday to 2:22, but just due to where the slowdown was occurring, the sensor never detected it and posted any messages on the DMS. And so to wrap up, we're continuing to compare the connected vehicle Q alerts with the sensor Q alerts, and hoping to, or we are planning on validating that with videos like I just showed to show the accuracy or evaluate the accuracy of both of the systems, and then continue to evaluate that throughout the 2025 construction season. Our hope is that we'll be able to go live with some of these systems during the next construction season if everybody feels comfortable with the accuracy of the system. And then similar to Michael's presentation, we hope to expand this to other applications where we traditionally wouldn't have invested the time and resources to deploy sensors. But if we have a PDMS, we can easily spin this up with no added cost or overhead to deploying the system other than setting it up. So with that, I'll pass it back to you, Melanie.
Perfect. Thank you so much, Skylar, and thank you to all of our wonderful speakers for this great information about the implementation of these Q warning systems. So we'll field a few questions right now. We'll start with the one that appeared earlier in the chat. This came up around Bob's presentation, but feel free, any of you guys, to answer. What would the minimum length of a corridor for the hybrid travel time to detection system to be effective? So what's that minimum length to get that hybrid detection system to be maximum effectiveness?
Okay, thanks, Melanie. I don't know that there is a minimum length of.
Oh, we're having a little trouble hearing you, Bob.
I got my mic one down. Sorry. I don't know that there really is a minimum length. I mean, you could do this as short as 2 or 3 PCMS if you wanted to construct across a short system. And the spacing that you want to put out is entirely based on your geometrics, the location of the work zone activity, and also as Skylar said, not overwhelming the public with too much information. So, yeah, I don't know that there's a hard and fast number for that. Which is a way of saying that I don't know how to answer the question. But I don't think that there is a true minimum. I think it's basically based on local conditions and what you're trying to accomplish.
Great, fantastic. All right, we have one more question for Skylar specifically, asking about Iowa. How is Iowa getting and sourcing the connected vehicle data?
Yep. So there's a few different vendors that are out there that provide the connected vehicle data. So the one that we are using is Streetlight. They're the ones producing the data for us. But there are other vendors out there, whether it comes from trucks or from other passenger cars. And essentially the data, what they tell us, comes from vehicle to our servers within 60 seconds. So it's really low latency in terms of getting the data from the vehicles to us being able to use it as part of our system.
Thank you so much. Feel free, if anybody has any additional questions, just to drop them in the chat here. Give it another minute or so, and if not, we'll end a little early, and we'll come back at the top of the hour at 2 o'clock for our next session. Oh, perfect. We've got one more question asking, how do connected vehicle-based queue warning systems handle unusual or extreme traffic events, such as accidents or sudden lane closures? So feel free if any of you guys would like to share your insight on that.
I don't know if we've looked into those sudden or extreme traffic events using the connected vehicle data at this point. But my assumption is we're simply just geofencing around the work zone, the approach of the work zone. So if any of the vehicles that are, again, heading towards the work zone that are traveling slow, that's essentially our trigger for posting the messages on the DMS. So I don't see, again, it's slow traffic, so it should just be posting the slow or stop messages. It would, in theory, behave exactly the same as any other, as our traditional system would behave. But yeah, it's a good point that we'll definitely need to look into to see how it handles it.
Yeah, I think that's exactly the wheelhouse we're looking for in our QBot, is for traffic events and accidents or sudden lane closures. That is what we're aiming to do. Now, using the INRIX data, we have a little bit more of a delay, as Skylar pointed out. Switching to CV would minimize that delay, but the whole point is you are rapidly deploying about the same time that emergency crews are deploying to handle those events. So really, it's right where we want to be on all that.
Thank you so much. We've got another question for Skylar asking, what is the remaining delay for you to process CV data and then post the messages?
Yeah, and that's a great question, WD. The first results that I was showing from the SWIZZ project was basically the raw data of, it was around 5 minutes from when the connected vehicle data would have detected it versus the sensor. And so that's the stage that we're at right now, because again, implementation is always a challenge, and there's going to be additional latency because it has to go through multiple steps to get to the point of posting an actual message on the DMS. So that's the point that we're at right now and trying to quantify that. Those examples that I did show at the end, the 6 minutes ahead of time, is the time that the message posted for the virtual connected vehicle data compared to the time the message would have been posted or was posted with the sensors. So we're still seeing that detection that those we're detecting the slowdowns faster using the connected vehicle data. But yeah, we need to quantify that actual time to posting the message, getting the information to the public, rather than just a theoretical time that we're seeing the slowdowns occurring. So it's a work in progress. We'll hopefully have some results soon, but they're looking still promising.
Okay. Awesome. Yeah, if you any other questions, feel free to continue to drop them in the chat. If not, thank you all. Thank you, Skylar, Michael, and Bob for your presentations and great insights. We'll take just a few minutes to break before we come back to the tool talk session. Thank you guys so much. See you in a little bit.
And as Melanie said, we'll take just a 5-minute break. That's just enough time to run to the restroom, but not enough time to make a quality sandwich. So hopefully we'll see you in just a few minutes. Thank you. Ladies and gentlemen, I want to remind you we'll be resuming our next session in just 2 minutes. Thank you. And we're back, ladies and gentlemen. Now, I recognize this title, latest with the Workzone Data Exchange, isn't something that probably got you up in the morning. But the truth of the matter is that the free exchange of data with an agreed upon standard is actually very cool technology. So we're going to drill down into that right now and learn about how just absolutely essential this is. I'd like to welcome up to our stage our moderator with ARTBA, Beth Stinson. Beth, take us away.
Good afternoon or good morning. I think it still might be the morning on the West Coast. Everyone joining us. It is my pleasure to open up this session, the latest with Workzone Data Exchange. Our presenter today is Ross Scheckler. Mr. Scheckler has a BS and an MS in aerospace engineering from Iowa State University and started his career in aerodynamic and structural design at Boeing Commercial Aircraft. During his career, Mr. Scheckler has consulted and advised many organizations, including NASA, the US DOE, the US DOT, the US EPA, the Army, and the Air Force. In 2005, at the request of the state of New York, Mr. Scheckler's company created a simpler, more robust traffic monitoring system. He established Icone Products, LLC, and a series of Workzone ITS products based on simplicity and affordability. Mr. Scheckler has been a guest lecturer in the Aerospace Department of Syracuse University and served as a president of Iowa State University's Industry Advisory Council. He has served as the vice chair of ATSA's Innovation Council and the chair of the Workzone ITS subcommittee. Currently, Mr. Scheckler is the co-chair of the CWZ Standardization Project. Mr. Scheckler has been a member of the Workzone Data Exchange since Ariel Gold first opened the conversation in 2017. Ross, take it away.
Okay, well, thank you. And I have to apologize to everybody. This is a little bit different session than we expected to have because Todd Peterson is not allowed to speak today because of all the things that are going on in Washington. I believe Todd is around in the audience somewhere, but going to be a little bit truncated. I'll say what I can. I have to personally be a little bit careful as I am here representing the associations that are in charge of the CWZ standard and not representing my own company. So I'm going to try and be a little bit circumspect, maybe a little bit short, and try and cover a few things that I know Todd wants to talk about. So I'm going to share my slides, if you don't mind. And there we go. Okay, so the world of Workzone Data Exchange, and I guess it's worth going back to the beginning. The concept of actively turning the Workzone equipment into connected IoT to deliver data to oncoming vehicles really sort of emerged from a early set of presentations myself and a few other members of American Traffic Safety Services, ATSA, went to visit the Automated Vehicle Symposium and give the first talks on the highway and what it meant to automated vehicles. And out of that came a bigger discussion about what the construction and the highway industry knows about the state of the road, and that the automated vehicle people didn't necessarily know about the state of the road. And back in, I believe it was 2017, just after the first Reagan administration started, Waze held a World Congress in New York, and Ariel Gold from FHWA attended and took a couple of us aside who were sharing data with Waze and said, we want to have a conversation about setting up a standard for collecting and distributing data on work zones. That's where all this comes from. And yes, 2017 was a long time ago, but in the world of highways, it was just the day before yesterday. And we've gone through a couple of renditions since then. Ariel kicked off the effort that was the Workzone Data Exchange, which set a specification for the protocol to exchange data. 2 years ago, approximately, there was a push from the industry and from the USDOT to move from a specification to a standard that would be something that would be maintained and move forward in the future under the auspices of AASHTO, ITE, and NEMA. And so that actually caused a little bit of angst amongst those of us who had spent 5 years getting the Workzone Data Exchange put together. And there was a lot of questions: why do we need this? Why do we need to go to a standard? And when it comes down to it, is it's one thing to have a specification on a protocol, but it's another thing to have the reason behind and the principles that created that specification, and that's the standard. And if we have a formal standard that is managed by associations that are professional at this, ITE, NEMA, and AASHTO are three great examples. Then when the time comes, if there's need to have a second or a different specification for doing the same work as that standard, the standard is the sort of the let's say the Declaration of Independence on why we did this. And the specification may be more analogous to the Constitution on how we're going to do it. So that's where that comes from. We started that work about 2 years ago, 9 months or 10 months ago now, in December. Version 1.00 of that standard was published. It is available on the project's website. It basically does the work of the Workzone Data Exchange version 4.2. We did add roadside units, RSUs, sort of preparing for a world where the data from the Workzone would go directly to the car instead of through a data center or through a state agency. I don't know, that's sort of a placeholder in it, but as it stands right now, you can think of the connected Workzone standard as the WZDx standard specification version 4.2. So what does the standard do? It basically defines the what we're trying to achieve in collecting and distributing data on the Workzone. It defines the structure of the data as really two separate feeds. There's the Workzone event feed, which is all of the information needed to understand the Workzone. Where the project is, when it's expected to start, when it's expected to end, details on who is executing the project, etc., etc. And separately, there is the device feed, which supports the Workzone feed. The device feed is the IoT equipment in the field that is streaming data as the equipment is activated. And that is picked up as signals that each individual steps in the process of executing the Workzone have started and ended. And so the device feed informs the Workzone feed. As a matter of practice, when all the devices in the state have been upgraded to an IoT standard, there's a lot more device data than there is documentation of formal work zones, because there's a lot of ad hoc maintenance work that's going on, that from utilities, counties, or municipalities. So a lot of that stuff showing up in the device feed. There's no other information on it. There's an error board here. There's a portable traffic signal there. There's a work truck in another place. That's coming out of the device feed. Not all of that has a one-to-one correlation with the Workzone feed, but the Workzone feed will have a lot more information, a lot more details on things like the expected start date, the expected end date, things of that nature. All of this is done in a GeoJSON. HTTP is the protocol for exchanging data. There are a number of systems already set up, and basically where we're at now is we've published the first version 1.00 of the standard. We are in a testing phase with a number of states and agencies around the country that already are working on Workzone WZDx versions 4.2. They're going through and they're applying the CWZ standard to that and making sure that it matches. I believe, and maybe somebody can correct me if I'm wrong, I believe that phase is expected to be finished this year, in which case the standard will be completely published and ready and out the door. And anybody who would like to, any agency that would like to participate in the testing phase, there's still, I think, an opportunity to do that. And you can reach out to the folks at ITE on the project website, which was on the first slide, and they will help you do that exact thing. So moving on to, this is a couple of years old now, but the WZDx event feeds are actually, I think we're now up to half the states publishing some sort of a WZDx event feed. I happen to know that for the device feed, I am aware of at least 49 of the 50 states where device feed information is available. Not sure where we are with Hawaii yet, but it'll happen soon. And this is becoming a real thing. And part of the message, I know this is the highway industry, but part of the message to the auto industry and the freight industry is there's a lot of good data out there. It's real time, it's accurate, it can be trusted, and there are more and more navigation and freight and auto industry users that are out there collecting this data and starting to build it into their operational models. We're not quite to the point where every car is warned of every work zone, but my firm belief is that within 2 years, we'll be at the point where 70 to 80% of the vehicles will be capable and will be actively receiving live work zone data. So for those of us out there that put boots in a hard hat on a regular basis, I think by the end of 2027, we can have good confidence that the large majority of the cars operating the road, whether they're running Waze or not, will be receiving data on the fact that we're out there and we're standing in the road and we don't want to be hit. So this has been great progress thus far. Just a quick slide on next steps, because I've had a lot of people ask me the standard writing process kind of put the specification writing process on hold until we got the standard done. But by the end of the year or thereabouts, we'll have the standard up and it'll be this standard. And it'll be time to get back to work on the next version of both the Workzone feed and the device feed. I happen to know of dozen different changes I personally would like to see in the device feed. And there's a couple of things that we might have to go back and break and then refix and make them work for adapted for a new view of all the devices that are going to be out there, and it's happening rapidly. And then there's sort of an open question that a couple of us have had in the background as the FHWA comes out with the MDODE, the Managing Disruptions to Operations Data Exchange. And one of so that's pulling in disruptions to your operations, work zones on the road, traffic incidents, weather conditions, things that disrupt the basic traffic operations on the highway. And the data associated with those three subject matters, all of that needs to be passed to those entities that are developing navigation products. There's a number of entities out there that are developing real-time navigation products for consumption into freight and passenger vehicles. They need all these things. The one question that a couple of us have been having is, it looks like the WZDx or the CWZ device feed actually supports both work zone and traffic incidents, and probably weather. TIMS and work zone both use arrow boards. They both use connected cones, connected trucks. Weather uses trucks out there with weather sensors on them. There are devices in all these things, and one of the bigger questions that myself and a number of others have had is, as we go into a world where we talk about the bigger tent of MDODE, should the device feed be sort of brought out of WZDx and made so that it supports all of the data collection from the field for the larger picture of work zone, TIMS, and weather. And that's up for discussion. I know there's another of people who have opinions on that, but that's kind of where we sit. We're hoping to move forward next year on the continued evolution of the WZDx spec under the CWZ standard. And that's what I have for you today. Thank you.
Thank you very, very much, Ross. And we do have another presenter today, sort of last minute joining in. It is my great pleasure to introduce Stephen Parker. He's the Managing Director of the Wisconsin Traffic Operations and Safety, the TOPS, Laboratory at the University of Wisconsin-Madison. In this role, he has led a wide range of research and development initiatives across core areas, including transportation safety, work zone systems, traffic management systems, and connected and automated vehicle technologies. Stephen has over 25 years of professional experience in applied technology, research computing, and in the last 2 decades focused on transportation systems with the University of Wisconsin Department of Transportation. Other agency partners. He holds an MS and a PhD degree in computer science from the University of Wisconsin-Madison. And he's going to share a presentation, Connected Work Zone Training Update. So please go ahead, Stephen.
Thank you, and hello, everyone. So I'm going to really pick up today largely from Russ's discussion and talk about a work zone data exchange and connected work zone training that the University of Wisconsin-Madison has been developing in collaboration with Iowa State University under the FHWA Work Zone Safety Grant Program. So there we go. So I think most everyone on in the meeting today is familiar with the Workzone Data Exchange. Some may not be, or some may need a refresher. But as Ross sort of described, the WZDx was a U.S. DOT-led Workzone activity data specification that was essentially developed to enable harmonized real-time Workzone activity data for third-party use. And a large focus of developing the Workzone Data Exchange was to support the safe navigation of both automated driving systems as well as human drivers through work zones.
Stephen, can I
Yes, of course.
Can I interrupt you for 1 second? We're not seeing your presentation. Are you
I'm
sharing
sorry.
the right screen?
I probably am not. So let's see if I can. Sorry about that. How's that?
There we go. Thank you.
Okay. All right. I apologize for that. So, okay. So the Workzone Data Exchange. Essentially, after those initial conversations in 2018, it was developed sort of collaboratively through the Workzone Data Working Group, all the way through 2024, going through essentially 4 major releases of the WZDx. In 2020, 13 states were awarded Workzone Data Exchange demonstration grants, which kind of expanded the use of the WZDx throughout the country. And then there's been additional sort of funding and opportunities since then, including several states that have SMART grant funding to also develop Workzone Data Exchange capabilities. As Ross mentioned, there are 2 sort of primary data feeds, a Workzone feed and a device feed. And essentially all of this was incorporated into the Connected Workzone or the CWZ implementation guidance standard in 2024. So this is a kind of maybe a more up-to-date map, really looking at the deployment of the Workzone event feed, the WZDx across the country. There's about half the states marked in orange that have active WZDx deployments. Several states are in the process of developing Workzone Data Exchange feeds, and many other states are kind of early stages of planning or really haven't kind of gone down that road just yet. And so the goal of the Connected Workzone training is essentially to paint the map orange and to help kind of those remaining states move forward with implementation of the Workzone Data Exchange, as well as to provide information to states that perhaps have an existing WZDx and maybe want to know more about how the Connected Workzone standard comes into play and sort of what's coming down the line in terms of modernizing and moving forward with their existing capabilities. So under this training, we're essentially developing 2 modules. We'll be providing what we're calling a CWZ 101, which is an introduction to connected work zones, as well as a CWZ 201, which is a little bit more advanced, deeper dive into the implementation and use cases of the connected work zone standard. The focus really is on the new standard. Certainly the WZDx specification is there in the background. The CWZ standard incorporated the WZDx 4.2 and kind of built upon that. But we're really adopting that terminology of the connected work zone. That's sort of the standard way of talking about these things. But a lot of times you'll sort of hear WZDx and connected work zone data exchanges used interchangeably. As I mentioned, it is part of the 2023 Workzone Safety Grant Program, and we're developing it in collaboration between Iowa State and the UW-Madison. So a little bit about the CWZ 101 training, which is our introduction to connected work zones. And this training will be largely geared towards agencies that are either just starting down the path of the Workzone Data Exchange and Workzone Activity Data Management, who maybe need a refresher, or as I mentioned, maybe you have some existing capabilities, but you either need to modernize or you're just interested in the impact of the new standard. So we'll be covering topics such as what is connected work zone data and why is it important. The bulk of this training will be an overview of the CWZ standard. We'll provide what we're calling a CWZ primer, which is really sort of a walk through the alphabet soup of terms, such as GeoJSON and HTTP and some of the terminology that Ross talked about, trying to give folks kind of a crash course in what all of that means. But we'll really be focusing on the two individual data exchange standards, the work zone feed as well as the device feed. Provide some real world examples and essentially close the training with some considerations on how to make the case for CWZ in your agency. I think most folks who have been in this area before kind of have an intuitive or maybe more intentional understanding of why CWZ data is important. The large focus for us in terms of this training, of course, is on safety, looking at motorist safety and mobility, worker safety, managing incidents within work zones, emergency vehicle routing around work zones, the safe and efficient movement of freight vehicles in and around work zones. But of course, we also know that CWZ is important for that broader kind of, mobility and navigation, especially when it comes to enabling automated vehicles, as well as the benefits of standardized work zone activity data management for performance metrics and performance management of your work zones. Ross sort of already talked about the two types of feeds that are sort of incorporated into the CWZ standard. There's the work zone feed, which essentially provides that high level information about the work zone event along the roadway, as well as the device feed, which provides information from from those connected devices in your work zones. With regard to the CWZ, the 101 work zone feed, the work zone feed itself is what most folks are familiar with in terms of the WZDx. It essentially describes the what, when, where, and how of a work zone event. Things such as the schedule, the duration, the location, the lane level impacts, detours if they exist, and so on. So we'll cover the topics such as the connected work zone data model and how to structure your work zone activity data with respect to the requirements of the work zone feed, mandatory versus optional data elements, which is very important when you talk about data collection and developing capabilities on existing work zone data collection capabilities that you have within your department. We'll step through a work zone data feed example, get into topics such as estimated versus verified elements. And so how do you kind of turn planned work zone data into field verified data? And that's really going to kind of get into the heart of the device feed as well as additional business rules and particular considerations for how to model work zone activity data for complex staging and geometry of work zones. In terms of the device feed, we'll cover sort of the purpose of the device feed in general, the benefit of connected work zone devices to the agency, the types of devices. Ross mentioned that there's many devices out there. The standard does incorporate most devices, and now it incorporates the RSUs as well. The property of those devices, how to link the devices in the field to your work zone events, and that's really where we get to things such as planned versus verified events, and how to essentially link the device feed with the work zone feed, as well as considerations for implementation. So really, I would say maybe the theme of all of this is moving towards connectivity and really starting to focus on that device feed and the importance of it to improve data quality, to share information with the public, eventually to share it directly through VDX communications, as well as to confirm your estimated or planned work zone data with real world and ground level information. So the CWZ 101 training is largely that kind of introductory level and, getting into some of the details, but really kind of up to speed with what the CWZ standard is about, what the Workzone Data Exchange is about, what GeoJSON is, and some of those things. The CWZ 201 training is a little bit more advanced. That will really kind of do more of a deeper dive into experiences from the demonstration grants, looking at those 13 states, guidance for Workzone data management, considerations when deploying connected work zones and linking connected work zone data with your Workzone event feed, as well as looking at individual use cases of connected work zones in the Workzone Data Exchange and different architectures that states have applied when developing capabilities. So this course is still in development. We do not have the actual time frame set yet. However, here are some information where you can go to find additional information, in particular information about when these courses will be available. What I can tell you is that what we're planning on is that the CWZ 101, which is that introductory course, will be available in early 2026. That's what we're anticipating. We'll be providing 3 90-minute sessions. You only need to attend one session, but there's 3 opportunities to attend. And then later, hopefully mid-2026, will be the 201 or the implementation and use cases training. We'll also provide 3 90-minute sessions as well. But participants really only need to attend one session from each module, 101 and 201. We really do recommend that if you're interested that you try to attend both. Some states who are pretty familiar with this and who have really active Workzone Data Exchange deployments may only be interested in coming to 201, but we do think that there will be good information even in the 101 in terms of what's changed between the WZDx and the CWZ, as well as some considerations about linking your connected work zones with the Workzone feed. So here's a QR code where you can find out more information. This will actually take you to the TOPS Lab website, which will give information about all of the trainings that we're developing under that FHWA Workzone Safety Grant. We hope that you stick around for the rest of the conference, in particular Thursday at 4 during the Workzone Safety Grant session. We'll be talking a little bit more about the other trainings that are available, as will some of the other states. So there'll be a lot more information coming about trainings and resources that will be available to you. And with that, thank you very much for your time, and looking forward to seeing you online during the trainings.
Thank you so much, Stephen and Ross. I really appreciate it. If anybody in the audience has any questions, please feel free to type them into the chat. We'll leave the chat open for a couple minutes. And we will post announcements on the Workzone Clearinghouse when the courses are available, and we'll post a registration link will bring you back to the information page so that you can sign up for those new courses.
All right, yeah, as Ross mentioned, unfortunately, USDOT and Volpe were not able to make it, so we do have a little bit shorter session this time. But I know we're happy to answer any questions that you might have in the meantime. We have about 25 minutes for them.
Well, we'll probably just end the session a little early and give people a break so they can make that substantial sandwich that Matt Moore said 5 minutes was not enough to make. So here's a question for you. Can you share some examples of where Workzone Data Exchange is being used and how?
So by WZDx, that could mean event data. That could also mean device information. And so there are deployments of both nationally. I think the best way, if you're interested in kind of knowing who has WZDx feeds out there, I would say the best thing is to go to the Workzone Data Exchange Registry that's managed by the USDOT. I don't have the link in front of me, but you can sort of Google on it and find it. And those are all public-facing feeds. In terms of, so I see there's more to that, referring to feeds to improve work zone safety. I mean, I think.
Well, if I may.
Yeah, sure. Yep.
So, yeah, the consumption of the event feed, there are, to my knowledge, at least a half dozen, maybe 10 major international navigation companies, auto companies, that are consuming both the event feeds and the device feeds. What's happening out there, in specifically in the passenger car automotive space, is the OEMs are trying to build a business model behind it, and so they're using some of their tier ones to assemble navigation mobility products that can be consumed. The obvious one, Waze was the one who made this all doable, because Waze was willing to accept the data, and they were set up to do that. That moved forward, and now that's part of Google Maps. But now we're into a whole ecosystem of companies that are operating and setting themselves up to be tier one suppliers to the auto industry. So that's coming. It's in the process right now. Those entities are consuming multiple sources of both the event feeds and the device feeds. It is a really rapidly evolving market space. But right now, from what we know in our company, somewhere in the order of 10% of the cars approaching a highway work zone are receiving data through at least one of the navigation tools out there, and that's going to grow very rapidly. As I said previously, I believe that by the end of 2027, somewhere on the order of 70% of the vehicles approaching your work zone will be aware of you before they can see you, which is a great step forward. And the exact mechanisms behind what the car or the truck does with that data, that's a OEM decision. How they treat their customers, how they, whether they you just have a chime come out of the dashboard that says there's a work zone ahead, or if they actually do something actively to the handling of the car, that's their decision in their customer care, and that's a hard problem to address. But the ecosystem is rapidly growing to put those pieces in order. We, as the highway industry, we had to do our part first. They had to believe that the data was going to be there, and they had to believe that the data was going to be right. And what the Connected Work Zone standard, what the IoT of work zone devices has done, is built belief in the transportation industry that those of us in the highway industry are going to share our data. And so, if it, as an agency or as a contractor, if you don't have a plan for this, it's time to have a plan for it, because it is happening. It is happening fast, and there's more to it than just buying a connected piece of equipment. If you own a fleet, there's fleet management issues, there's data security issues, there's data rights issues, privacy, liability, all these things come into the picture. And there's going to be 10 years of discussions about data rights, data privacy, liability, and all the things that come with this. But we are going to wind up a much safer industry when the cars can know we're there before we come over the horizon, and when the cars can know we're there when there's a computer driving the car instead of a person driving the car.
Yeah, that sort of segues to the next question. Can I read that? Are we good? Or did you want to contribute, Stephen?
Yeah, sure. Well, I was just going to add, I would say that the development and some of these trainings are about, it's not just about the data exchange standard itself. It's really helping these agencies improve their existing work zone activity data management capabilities, because it's the data behind the communication and the exchange. And so a lot of agencies that are starting to look at the data at the WZDx and the CWZ standard are improving their systems and looking at how they collect data and how they connect data so they can provide that reliable information. And I think underlying all of this is that timely, comprehensive, and accurate data is the foundation of work zone safety. So it will be used more as it it becomes more ubiquitous throughout the state, the country.
Great. Okay. So our next question, is there a role for highway construction contractors in leading the adoption of new work zone data exchange tech, or is it going to be on the state DOTs for tech to get incorporated?
So far, from our experience, is 90% of the adoption has come from contractors who want their workers to be safer. They actually, so what's interesting in the world of connectivity in automobiles is the work zone, the infrastructure that you're connecting is privately owned. The arrow boards, the message boards, the trucks, the cones are owned by contractors. And they have their own motivations. Traffic signals, and we want to have all of our traffic signals connected so the cars can know when it's going to turn green and red and everything else. That's fine. There's 400,000 of them owned by 10,000 different governments. And that's that's got its own problems in actually going through and connecting all of those. But where the contractor comes in, you guys own the equipment. You own that arrow board that's sitting out there. And you guys have the liability and the safety of your workers. So what we've seen is the vast majority of adoption has come from the big, very safety conscious contractors who are going to do whatever they can to lower their liability and protect their workers. And the reality is, from our numbers, and Skylar, who's listening, can back this up, Iowa has statewide adoption of connected arrow boards and now connected portable traffic signals. We send a ton of data to Iowa, and 85% of what we send is not on a known state project. It's a municipal project, it's a county project, it's a utility, or it's a maintenance project that is just not in the database anywhere. 90, I think when you include utility companies, 99% of the equipment is owned by contractors. The contractors need to lead this, and the contractors have the financial and safety motivation to do it. And so that's what's been different about this. It's going to take a long time to convince every municipality that has a traffic signal to invest $50,000 making that send dispatch messages. But if we can make the economics and the safety work, the private sector contractors are going to make this change very rapidly, and that's what we've been seeing. There's a question about data security.
Yes, there's one little qualification question. When you're talking about being aware of you, does that mean you're aware of the workers or aware of the work zone?
That's so when you start to track individual workers, there's a lot of discussion to be had. There's been a lot of discussion in WZDx about workers present, what that means. It's a legal term in most states. Many of the states where it is a legal term, nobody can tell you what it legally means. It sometimes just means what the state trooper says it means. There's concerns about tracking workers because you're starting to get into privacy issues. And the industry as a whole is going to have to consider that. But certainly there is an active work zone with some workers present, maybe not an individual worker, but some workers present, is something we do have to get to. And certainly a work truck with its light bar flashing is a pretty good indication that there's an active work zone and there's workers present. whether we're going to track individual workers and whether that's going to work in a union environment. That's going to be something we all have to talk about. That's something that this group should talk about. There's a lot to be said there. One of the things that we do, just in this is sort of a humble brag. Whenever we share data out to a data consumer such as Google, we generate a one-time unique ID for that data, so that if it's your work truck and you're tracking whether the lights are on or off, and you pull into a site, you turn your lights on, that data goes out and it's identified, and it has to be identified per the standard, so that other agencies can recognize it's the same data point. But what we do is we identify it with a one-time unique ID. When you turn that light off and turn it back on again, it's a different ID. And that's done specifically because we're worried about privacy. Because sometimes that work truck goes home with people. Sometimes that work truck puts in a 12-hour day. And heaven forbid, a worker goes out, puts in a very long day, is on multiple sites, and that's data's being shared with the world through a Google or an Apple or a Inrix or whatever. If there's an accident at the end of that day, we don't want a record out there that truck was covered 400 miles and worked a 12 or 14-hour day. That's not what we're doing here. We want to protect that kind of stuff. So there is, and I'm sort of leading this discussion in ATSA's risk management group about these issues of privacy, data security. There's a need to maintain chain of custody of data. I as a IoT company need to prove that I did my job and I took the data from the field and gave it to the navigation company. Just the same, the contractor needs to do their job and make sure their equipment's working. And then you need a receipt from me to prove that your equipment was working. And I need a receipt from Google to prove that I gave them the data. All these issues are things that are going to have to be worked out. This is a reason to get involved with the CWZ, get involved with these groups, because whether you know it or not, the world knows you're there on the road. And you're not going to be able to, say, nobody's going to know, or I don't want to know. Here, I hear a lot of states saying, I don't want to know that my attenuator was hit. Yes, you do, because the world knows, and you need to do your job. And that's a little scary. But for the professional organizations, they're not afraid of it. The mom and pops who are operating on a shoestring, they have a hard time with it. But these are things we have to talk about. That's why this is an important session. That's why CWZ is important. That's why what Steven's doing is important. There's a whole host of new things that happen to your business when you work in a connected world.
And that sort of segues into what is being developed to maintain data security and integrity moving forward into the potential of quantum computers.
Stephen might be better than me, but I kind of just dumped what we're doing.
Well, I think I can't really speak specifically to connected Workzone devices. I think that data security and integrity when it comes to field devices is a concern. I think it's largely around spoofing, information spoofing. But it's a broader concern. I don't know that necessarily it's an issue right now. Most of what's in the Workzone Data Exchange is publicly available data, but we want to make sure it's accurate, and I think that's where some of the data security and integrity comes from. But I can't really speak to any specific, focus right now on, the impact of quantum computing and what's going to happen necessarily, in terms of information security around those devices, more than what is going into all devices in the field. But I don't know, Ross, if you have more to say about that.
Well, one of the things that needs to be understood is I think we all remember or have seen a zombie alert on a message board somewhere. And everybody, oh my God, how did that happen? Well, part of how that happened is nobody ever changes the password on their message board when they buy it. Change the password on your message board. Let's start there. But the world of connected workzone is actually a different protocol. The message board is a modem, a computer that you can dial into and you can program. You can put up a message. For the most part, connected workzone and like the arrow board's a great example. Arrow boards aren't all that smart. But the world of connected work zones is a passive monitoring of the equipment in what's an Internet of Things framework, where the device in the field is turned on and it automatically reaches out and reports to the center. It's a one-way communication protocol. So the control is that at the device in the field calling a known computer that's expecting it to speak in a given language. And if anything is tampered with there, nothing works right. For our system, the device serial number, the IMEI of the modem the device is calling from, and the identifier of the SIM all have to line up. And then it has to speak the right language, and it has to call the right computer. And when you start to stack those things up, you wind up with a very secure system. So that's part of the nature of IoT. We monitor thousands and thousands and thousands of arrow boards around the country. We are not advocates of remotely changing an arrow board because the guy on the ground needs to do that. And so it's a different world. What you're really more concerned about, in my view, is privacy and proving that you did your job. So you have a receipt that says my equipment worked. In my case, as an IoT provider, I have a receipt that proves I delivered the data to Google. And those kind of protocols, other than that, it's a very secure system. Some of the smaller companies in the space are actually contracting with the bigger companies to provide that connectivity and all that backbone. So what's going to happen is even very small companies, we have companies with us that only put 10 units out a year. And we provide that backbone for them because they're too small to do this. And so that's one of the things as a contractor, you want to pay some attention to who you're working with. What are your rights to the data? What are they doing with the data? What proof are they giving you that they're doing their job? How are they helping support you do your job? Those are all the pieces of this. But the actual security of the communication, it's hard to hack one. It's really hard to hack 10,000.
Yeah, I guess I'd just maybe add, one of the things you mentioned about privacy, when it comes to, say, worker presence, some of the concerns out there, for example, with wearable vests, or even just having, say, a piece of equipment in your truck, which you may then at the end of the day pull into your driveway. Those are some of the concerns that folks have in terms of where that information is showing up, and that's going to be largely based on standard operating procedures and kind of how to incorporate those into the business. So there's as much sort of a business process as it is sort of securing the protocol and securing the devices, and all of that will take time to work out. And there are concerns out there with some of those things.
And Beth, we filled your hour.
You did. I'm so happy. Thank you so much, Stephen, for jumping at the last minute. And Ross, incredibly interesting work about data. I mean, I haven't thought of some of those points that you brought up. So thank you both very much. I will turn our meeting back over to Matt, and we can go from there.
All right, thank you, guys. I told you that was going to be a really informative session. So we'll begin again in just 6 minutes with safety in commercial motor vehicles. So very excited to share that with you. Once again, we'll see you in just 6 minutes. Folks, we'll be back in just 2 minutes with our next session, our 3 o'clock session, Safety and Commercial Motor Vehicles. So buckle up. We'll see you in 2 minutes. And we are back. Welcome back, ladies and gentlemen. I'd like to invite from ARTBA, Isabel George, to come on up and join us on the stage for this very important session, Safety and Commercial Motor Vehicles. Isabel, take it away.
Thanks so much, Matt. I'm really excited to introduce our presenters for this next panel. First is Sarah Hacker, a research program manager and data analyst at the Herbert Wertheim School of Public Health at UC San Diego. Sarah currently works with Dr. Linda Hill and transportation research and education for driving safety on a variety of transportation safety projects. Her educational background is in psychology, cognitive neuroscience, and statistics, and she's used this to study driving behavior in a variety of populations. She has written and acquired multiple grants, including from FMCSA to address countermeasures for impaired, distracted, fatigued, and restless driving in CMVs, passenger vehicles, pedestrians, and rail. Second is Chris Brooks. Chris is Michigan Department of Transportation's Workzone Delivery Engineer, and he's been with the department for over 17 years. He is a technical member of the National Committee on Uniform Traffic Control Devices, Temporary Traffic Control Committee, and an active member of ATSA. He holds a position on the Temporary Traffic Control Committee and the Innovations Council at the national level, and is on the Michigan ATSA chapter board. He was also the recipient of the ATSA National Safety Award in 2017, as well as a recipient of the 2024 ARTBA Safety Traffic Industry Division Jake Landon Highway Safety Award. Chris is a proud father to 2 delightful boys, Ryan and Jack, and a wonderful little girl, Zoe. Chris has a bachelor's degree in civil engineering from Michigan State University. Go Green. And finally, we have Matt Weaver, the Vice President and Traffic Engineering Group Manager at Element. He brings more than 20 years of experience in traffic safety and traffic design, with a focus on safe system approaches and solutions that address user behavior. At Element, Matt manages multiple safety-focused contracts across Florida for both municipal and Department of Transportation clients. Before joining Element, Matt worked for the Florida Department of Transportation in various traffic operations and safety roles. He was named the 2018 Joseph Grimale Transportation Professional of the Year by the Tampa Bay chapter of the Institute of Transportation Engineers. Welcome all 3 of you, and I will pass things off to Sarah to get us started.
Thank you so much, Isabel. I appreciate it. All right, let's see if I can share what I've got going on here. Oh, you can see yourselves. There we go. So I'm here from sunny San Diego talking to you today about how we use real-time driver alerts to hopefully improve commercial motor vehicle safety in work zones. Our we are a research group out of UC San Diego called TREADS, the Transportation Research and Education for Driving Safety. Excuse me, we just rebranded. We're still getting used to the new name. And we are directed by Linda Hill and Ryan Moran. So it's not going to be super surprising that CMVs account for a disproportional amount of fatal work zone crashes. They make up about 5% of all vehicular traffic, but about 30% of all fatal crashes in work zones, and not particularly surprising given the size and the amount of damage they can do, how vulnerable other road users are around large vehicles. And so we know that this is a particularly large issue to tackle. We found the same thing to be true in California specifically over the last 10 years or so. Despite the number of fatal crashes and fatalities in work zones overall in California from vehicles, commercial motor vehicles make up a steady 20 to 30% of that, no matter whether or not the trend is going up or down in those ways. So we wanted to know if active work zone alerts could improve driving vehicle safety. And we did this in a couple of different ways. We took a look at different data sets that were available to us. So Caltrans has this really fabulous commercial warehouse web portal. It is open source, it is available, and it gives us the number of active work zones and their type and the number of lanes that are closed and a lot of different really helpful information thereof that we can use. I'm so sorry, I'm still trying to figure this out. There we go. Really important information that we can use. And we worked with a company called DriveWise to take messages that driving fleets had already signed up for. So things like if there's traffic congestion ahead or things like that, so that truck drivers can know what the best path to take is and that sort of thing. And using MUTCD compliant and hands-free ELD logging devices, which are now pretty much mandated everywhere, we're able to provide alerts that are also available for other scenarios for work zones through our partners, DriveWise. And we didn't pick DriveWise specifically. They came to us and we partnered, and we have a lot of tech partners. And the beauty in working with research organizations like ours and for us to partner with tech organizations is that what we can do is determine the fidelity of what they have going on, but we do it objectively. And so if it's going to work, we'll tell you it works. If it's not going to work, we'll tell you it doesn't work. And so we take our mission as a research organization to objectively sort of look at the efficacy of these technologies very seriously. So as we are able to, we can look at both a experimental group where we're providing these alerts to ELDs and collecting anonymous vehicle data like speed braking, but we also do it in a control group. So we have all of the same information about how they are traveling through work zones, but without them actually seeing the alert, we can determine how effective the alerts are. So there have been a few other studies that are like ours that have looked at how vehicles are responding to alerts like these, but without a control group, it's really hard to determine whether or not it's actually due to the alerting system or if it's just a product of the environment. So we definitely wanted to look at measurable changes in behavior like speed and frequent braking. And our overall goals are to work towards things like reduce CMV-involved crashes, right? So when we saw that piece of information before, and we noted that CMVs are overrepresented. We're trying to see if there is a way that we can mitigate that in any given way. And we want the perception, we want to understand how drivers, driver supervisors, and road workers are being helped by these technologies or responding to them, or what other caveats there might be. And so I caught the tail end of the last session, and they talked a lot about data, technology, and anonymity, and we are all for those things, and we want to make sure that we are stewarding that appropriately. So to sort of describe what our study looked like, for several months, we took the DriveWise, not us, DriveWise took the data from Caltrans and their work zones, and they fed it into their system, and they are able to sort of create a geofence, right? Sort of an invisible barrier about 500 meters out from any given work zone that they have in their system. And I'm going to go back just really quick and show you, these are the counties, the Caltrans districts that we looked at. 2 you can see is way up north. It's up near Shasta, it's up near the mountains, and then we look down in our area at District 11, and then 7 is where we're actually currently collecting data right now. So everything you're going to see today is preliminary, but it's really important to note that we didn't look at absolutely all of California. We picked regions because looking at our very vast state is expensive and time consuming. So we did take a look at a couple of different key districts from Caltrans. And so the Caltrans designated work zones are fed into DriveWise's system. They're able to give CMV drivers through their ELD for fleets that have already signed up for these alerts. They're just getting them because they've already signed up for other various alerts through the DriveWise company. And so we're not asking them to buy anything. We're not asking them to do anything extra than they already do. These fleets have already signed up for alerts, so this is just an additional one that they get now. And so 500 meters before a work zone, they'll see something that says work zone head, slow down. We collect data from about 30 seconds ahead of that message display to about 5 minutes after, because we want to capture the full breadth of vehicle behavior. And so getting that sort of pre-behavior and post-behavior is really important. And like I said, the control group has the same course of data collection, but they see nothing, they hear nothing. They come upon a work zone and nothing flashes on their ELD related to that work zone, but we do receive their vehicle's data in order to compare it. So we sent out alerts for a good chunk of last year, April through December. We had 4,000 unique work zones of a variety of categories. So anything from we're doing vegetation work on the side of the road to we are working to repave this part of the highway. So some of them are sort of high impact and some of them are low impact. Some of them are sort of in the middle. Caltrans also does give us information about how long these work zones are open and whether or not some of the lanes are closed. And we'll talk about that in a minute. So initial findings didn't indicate a whole lot. And so what we decided to do was think about whether or not it was impacting individuals that were driving on the faster side or the slower side. Because what we found when we looked at simple rates of speed leading up to these work zones, the average speed of any given CMV in California going up into a work zone was well over 50 miles an hour anyway, and our speed limit's 55 for commercial motor vehicles. And so we were seeing speeds of 50, 60, 70 miles an hour and going, if that's close to the average, then that is a problem. And so we split it up, thinking that if those are going under 55 are either obeying speed limits, performing safely, or they're hitting traffic as a result of either time of day or anything like that, then maybe the alerts are not working quite as well for them. And so we split the groups between the over 55 and under 55. And in fact, we can see a little bit of a difference in the slowing for the alerted group compared to the controls, which is good. They're just slowing down a little bit more and a little bit faster. Right here, we're only looking about 10 seconds after alerts. We want to know sort of what the immediate reaction to those things are. But it's with the volume of vehicles that we have, and speaking from a data perspective, I'm a data analyst. If you have a lot of vehicles and a lot of data points, you can make significance out of just about anything. And so we want to take this with a little bit of a grain of salt, right? We can see that the speed difference is not a whole lot, but it is a promising trend. So the next thing that we decided to look at is the addition of specific lane messages. And this was really important to us as well, because we have the information from Caltrans about whether or not lanes are going to be closed ahead. We can actually tailor those messages to give them more specific information, like left lane closed or right lane closed ahead. So we looked at those compared to both the, let's see if I can get this going. So compared to both the control and just the generic messages. And we found that within the first 10 seconds of those who received specific messages, whether or not they were going over or under 55, we had a more significant rate of deceleration in those groups. And so even though all over, we're not seeing much of differences here between this and this, having the lane-specific messages sort of makes a difference. And that sort of makes sense to us on a behavioral level. We're thinking that if you get a message to slow down, but the work zone's not active, or it's in the middle of the night or something like that, you're less likely to take heed, perhaps, and immediately throw on your brakes. But if you're indicated that your lane ahead is going to be closed, then you're poised to pull your foot off the accelerator, sort of make a judgment about whether or not you need to switch lanes and continue on. And so we were encouraged by these particular results. But it's not just the vehicle data that we were interested in, because the vehicle behavior can only tell us so much, the speed and the braking. We actually really wanted to talk to drivers as well about whether or not this was helpful or hurtful or distracting, right? As a neuropsychologist, knowing what cognitive overload multiple messages can have in the vehicle cab is distracting, and the limitations of attention. We wanted to make sure that we weren't over alerting, and that we weren't being obnoxious, or that our alerts were even effective at all. And so the good news is what we found was that of the people who knew that they were getting these alerts, they were also able to pay attention to their surroundings more. So even if we're not seeing the, braking events, if we're not seeing the slowing and speed immediately, if what these alerts can do is provide an extra measure of, oh, I should be looking around and paying attention and keeping my eyes out for orange cones and workers and other trucks and lanes switching and things like that, that's encouraging to us. We want to know that drivers are seeing these things and that they're making sense. The other thing that we asked, and it's not specifically stated here on this slide, but the other thing that we asked when we asked drivers if these were effective messages is how the timing was and all of these things. And we were getting quite a bit of feedback that on occasion, the alerts were coming not at a good time for them to prepare for a work zone, or that they were even coming after a work zone. And that's a problem, right? If you've already traversed a work zone and then all of a sudden you get a message that says work zone ahead, slow down, and you're like, well, I just passed that one. That's not helpful. We were able to take the feedback from these drivers and make adjustments to the program, right? DriveWise was a great tech partner here in their ability to take that feedback and make adjustments to how they were alerting drivers. And so in the second phase of this project, so you can see that this is driver survey round 1. In round 2, we actually increased the distance. So when we're thinking about that diagram at the beginning about that geofence that's about 500 meters out, we actually increased it to 2 miles and then ran the experiment again, collecting data from vehicles to see if reporting work zones further out was more effective. And that lines up with what we were seeing at the beginning with how fast vehicles are going as they enter work zones, that if we calculated 500 meters because we assumed everybody was going 55 miles an hour and less, but they're not, then maybe a longer runway up to a work zone would be more helpful. So we did just that, and we're collecting that data now. The other key finding we found in, and I'll wrap up pretty soon so my colleagues can get to their parts, but another one of the things that we looked at and found that were very distinct were the actual 2 different districts that we looked at. And this is just an example of that. But when we look at the volume of vehicles that are running through hour of the day, so if we're looking here down at 0 is midnight up through 11 p.m. at 23. This is the volume of vehicles. And in that sort of lighter color is District 2 up north. It's very rural. It's very mountainous. There is quite a bit of CMV traffic up there related to agriculture and shipping up into Oregon and Washington, whereas San Diego County, Imperial not so much, but San Diego County down in District 11 is very urban. It's very heavy traffic. We're right along the border down there, so there's a lot of heavy CMV traffic along the I-5 freeway, which is the main one that runs up through California, and that the amount of vehicles that are running through certain areas, these curves tend to look very different when you're looking at the 2 districts, and it's caused a lot of trouble when looking at our data in an aggregated way. And so as we continue to tease out what the different scenarios and environments that these vehicles are going through, the different ways that the work zones themselves are impacting, we also have to look at how the regions are affecting the way that we interpret our data. So there's a lot of different things that we need to look at as the data comes in. And like I said, this is all preliminary data as we go on. But to my last slide, looking forward, we are actually currently wrapping up our collection of District 7, which is Los Angeles and Ventura County. And we're actually really excited to see what that data looks like, because Los Angeles is urban, much like San Diego, but they are far more urban than we are, and they're actually quite a bit more spread out. And they have a high amount of industry compared to San Diego County. And so we think they'll look a little bit more like we do down here in District 11 compared to District 2, but we're also expecting some differences. And like I said, we're looking at that change in distance from 500 meters to 2 miles, hoping that what we are going to find is that it's a more effective alerting distance. And we're going to continue to follow up with our drivers to see how these work zone alerts are impacting them. We have gotten quite a range of responses. Some of them hate them, some of them love them. There's always going to be a bit of a range, but in general, we're finding that they are helpful, that they're not too annoying, and once we change the distance, the message that we're receiving is they're a little bit more timely, and that's important. And we're going to continue to look at this data and hope that in looking at these different regions, we can identify some things that sort of translate outside of California as well. And that is it for me, and I will hand it over to our next speaker, and I appreciate your time. Chris, you're up.
Awesome, thank you. So I'm Chris Brooks. I'm the Workzone engineer for the state of Michigan, and my presentation is going to be on some of the grant work that we've done, and it really is going to build off of majority of what the speakers have talked about today. Just kind of getting into it, looking at Michigan data specifically. We did have 6,252 CMV related crashes from 2024. And a lot of those go into the fatigue, driver not paying attention type crashes. But what I really want to get into is kind of highlighting some of the things that we've done to try to prevent this. So we're really looking at leveraging all the things that we've talked about. You heard Ross talk about the Workzone data exchange. You've heard others talk about, the connected devices ranging from traffic sensors to worker vests, integrating that system into ways. We've done some things over the years with connecting our Workzone information and trying to get it in front of a vehicle. We did it with a GM Chevy Tahoe a few years back. So that was kind of our first dive into this. But with this project, what we had is we had an FMCSA grant. We had two projects. One is almost near completion. That is the Safe Zone project here, where we are looking at really our static work zones. And then we also have one that is currently ongoing as well still, where it is pause, where that is looking at more of your mobile operations, your striping and things like that. So today I'm going to focus on the Safe Zone project and really highlight some of those. But I think it's important to know that we do have the two separate ones going on, because as I believe everyone on this call is probably aware, there is a drastic difference between your static work zones versus your mobile, short-term, short-duration operation type work. And I'd be almost willing to say that sometimes those pop-up work zones are really the ones that are causing the problems over that long-term construction where people are used to getting the alerts or aware of that backup. So really, these are all our partners. This is kind of how it's working. I really want to get into kind of the meat and potatoes, so I'm just going to gloss over a couple of these slides and really kind of highlight what we've done and kind of getting some of those field results and that field data. So just once again, highlighting what are we doing, what we have out there. We're using trailers, other different technology to really do that with video detection and things like that. But we have a really nice video highlighting our project, and I'm just going to play that because that does a really great job of kind of going through and describing how we got to where we're at. And there is a QR code too, if you want to take a picture of that for looking at it later or sharing it with anybody else. So hopefully this plays and we won't have any issues with sound.
Commercial motor vehicle crashes accounted for 41,854 incidents on Michigan roadways from 2017 to 2019, resulting in 283 deaths and 893 serious injuries. Of those, 1,739 occurred in work zones, including 15 fatalities and 31 serious injuries. The Michigan Department of Transportation recognized this serious problem, and in 2021 received a grant from the FMCSA to deploy advanced work zone technology with the goal of reducing such crashes. Using roadside video analytics, smart work zone devices, and vehicle-to-everything communications, this technology will alert commercial vehicle operators to changing work zone conditions, such as the presence of workers, approaching lane closures, and the formation of queues. Deploying this technology using mobile solar-powered trailers means no existing roadside infrastructure is necessary, and the system can be easily recalibrated as worker crews move throughout the course of construction. Calibrating the system is as easy as drawing shapes on paper, with notifications activating based on object motion or presence in defined alert zones. Conflicting objects or areas that should not trigger alerts can also be easily masked out to avoid unnecessary false alarms. Having multiple cameras on each trailer means multiple viewpoints are possible, maximizing coverage. Once the cameras are calibrated, they detect and track the movement of objects, including being able to distinguish personnel from vehicles. Each detected object has GPS, speed, and heading information calculated by the camera based on its position and movement relative to the camera. Object data is then fed to a small computer in the trailer's cabinet enclosure, which processes the detected object information and generates connected vehicle messages. These messages then get broadcast via roadside unit radio installed on the trailer mast. Such messages can be received by devices called onboard units installed in participating fleet and freight partner vehicles on the project, or any other equipped vehicles that may traverse the work zone, producing in-cab alerts and notifications about work zone conditions and objects. Personal safety messages are produced by the system for all detected personnel. Basic safety messages are produced for all detected vehicles. Personnel that leave a protected area, such as by walking outside of a temporary concrete barrier or operating in a lane closure only protected by barrels, will trigger special traveler information messages that warn operators of unprotected workers.
Look out for workers.
These messages will enable the equipped commercial motor vehicles to see and display the presence of those objects and greatly increase operator awareness of their surroundings. Other components of the system produce messages as well. Smart work zone devices integrated with cloud software will also detect the formation of queues and the activation of lane closure arrow boards. This information will generate traveler information messages produced by MDOT's back-office connected vehicle ATMS and broadcasted through the trailer radios, warning operators of upcoming queues or of the need to merge lanes. Passively, the vehicles themselves will be able to identify the upcoming work zone and notify operators that they will soon need to decrease their speed. Connected vehicle technology has been proven already through countless demonstrations and proofs of concept. MDOT's project pairs this established technology with new and upcoming tech, like advanced video analytics, to show the incredible flexibility and versatility of this technology. Achieving Vision Zero will require creative and innovative solutions to protect our most vulnerable road users and solve our most challenging use cases. MDOT hopes that through this deployment, the commercial motor vehicle industry will recognize the immense benefits, encourage adoption, and hasten its deployment, both in vehicles and as a standard component of work zone traffic control.
So that does a pretty good job of giving us an overview of what we've done, but I'm a big component of actually letting everyone kind of see what this actually looks like in the field. And so this is a video. I apologize, it's not the best quality, but this is actually the onboard unit that's installed in my personal work truck. And this is the messages that were being displayed and how they come up in real time. And I'll try to kind of narrate through this a little bit too, but I also want you to hear the volume and the sound of those alerts as they're coming through. Apologize for my radio, but I had to have the sound on, and I didn't turn the radio down purposely. As you can see, the screen changes, and it tells you what is going on. That is crystal clear to the driver. It is a slow traffic ahead message. This was being broadcasted and alerted automatically because I was doing a test run to make sure my vehicle could accept that message and see what it looked like. As you can see, it says slow traffic ahead. As you'll notice, there is some gaps in the alerting, and that was due to how the segments were defined. And that got into a little bit of what Sarah was talking about with her presentation in that alerting time frame. But I'll get into that a little bit more here with another example of what we were seeing. So we had the ability to take that queue warning message, put it in front of the drivers, telling them that there was slow traffic ahead, that they were approaching. We had sensors that were on the side of the road, our standard queue warning system that was in place with additional sensors, roadside units that would then be broadcasting that information out from those trailers. We also had, as you see here, the speed limit reduced, and when the travelers were going 5 miles per hour over or greater, they would be flash the speed limit sign, and that annoying little bell, almost like a seatbelt warning, would continue to go until you slow down. And like I said, I'm a big component of testing these things. Here is the example of where we had worker presence, where we had workers ahead. And what you'll see up here on the right coming up is where we had a location where they were putting in a box culvert, and they had limited protection in that area and were getting really close to traffic. So that is how we were detecting it. Once again, this was done via just a time and turned on. But as you'll see here on the right, the camera trailer that is out there, I slow the video down here in a second, that is out there would have that video analytics on there, would be detecting those workers in that area. And if they were there or present, that would be when you'd get that message. If they're not there and they're not detected, that would then go away. The nice thing about this is, as you'll see here, the message then, once you get out of that area, then just drops off. So the duration and the time of that message was very appropriate. One thing that we ran into as an issue that Sarah somewhat alluded to was we are saying that the work zone is 0.3 miles ahead still. For those of you that are on in the world of work zones, I'm sure you can imagine and think, well, Chris, there's barrier wall right there. Aren't you actively in the work zone? Yes. This was something that we found out was done via, we used the planned location of the work zone and not actually devices in the field to identify when that alert was coming for the work zone ahead. And not having that tied to those alerts was something that we realized created that issue or that concern of those not lining up. So making sure that you have that physical starting point tied to a connected arrow board or tied to an item that is physically out there is really just, to me, drives the need for that validity of the data to be there. So really, that's just getting into that. So, and really what we're trying to do is get those expected benefits. We're trying to reduce the crashes. We're trying to do everything that everyone has already talked about and looking at that. So we're really trying to take this information and make sure that it was going there correctly, appropriately, at the right time, and we were getting it to the road users. It wasn't annoying. So really doing a lot of the same work that Sarah was doing, but really kind of focusing more on, what does that look like from the driver perspective? How is that being processed? And as the DOT, what information needs to go out there and how do we need to do that? We are hopefully, this is still tentative, I believe. We are working with hopefully some Iowa University, Iowa State, with Schuyler and Melissa Finley to possibly have our project looked at and look at the data around that to see kind of what results we had from those alerting mechanisms and how that went out. So we don't have the data. Their final report is just being finished up and will be turned in here very soon. But we're hoping to get some data out of that. We have a lot of lessons learned. I've learned a lot of different things from this and different items to be aware of when kind of taking into account more of the practicality of putting this out there and getting it working in there. So a couple of the things that we ran across were just making sure that the onboard units were delivering the alerts at the right time and not while the vehicle was in the work zone. The trailer placement was really important to how it was out there. If we had the trailer too close to the road or to the shoulder, we weren't actually able to detect the workers and where that was going. Making sure that the Q1E messages was going around. We were tracking the real-time locations. One of the things we also realized too is that when we were actually detecting the workers or using the camera analytics, the size of the image and the object was definitely a factor. And there was once or twice where when we first went through, we had a drum be identified as a person, but we got that fixed after looking at some of the pixel and some of that size. So we had a lot of lessons learned on that. There was some limitations. We had pretty much all of them worked. We did have one issue with one of the trailers not working. And then we're still kind of processing and waiting on the operator feedback. But the one thing that we did have to do is we did have to put these in every single truck that we were testing with. So we definitely want to make sure we have those early alerts. And the question I have is, when is too early? That's one of the things that we were talking about too. Is 2 miles out from a work zone too early? Because people forget or they get distracted. Making sure we have correct placement for the coverage, we identify those gaps. The camera limits and the curvature of the roadway really has a lot of ability to either expand or shorten the alerting area of what we're detecting, how the contractors are staging their work, and how much reconfiguration is needed if we're moving the trailers. On our projects, they were concrete patchwork. So as you know, the work crew is moving on the roadway, so we kind of selected some locations with a really high patch quantity where there'd be a lot of work intensity. But we didn't move them throughout the course of the project just due to the calibration aspect. There was a little bit more in that than we realized to get the cameras up on top, lined up, and then code in that work zone area for the analytics. We did, obviously get it out there. We had different things that we looked at. Pretty much a lot of the stuff worked pretty smoothly from that side of things, but there was a lot of different testing that we did just to make sure that what we realized we were putting out there was actually working and give us that right information. And then here, just kind of give you an idea of what the smart HUD and things like that looked like as that was being displayed. So it was basically a mirror that was reflecting that back to the driver. So I've been driving around with that in my vehicle for some time. It is pretty undistracting. Gets a little annoying at times at night. It's a little bright, but that's something that probably could be tweaked as well too. But for the most part, it works. We integrated it and are looking at integrating this into a couple of our different vehicle types just to make sure we were having that testing and getting that and connecting different things. So we are working with the Haas Alert Unit 2 to really tie in that worker's presence when those come on. But all in all, everything that we kind of had really is taking all of that information that everyone's been talking about, from the Workzone Data Exchange to the smart devices to all of that, and integrating it. And I feel like this is kind of one of those first times that we put it out there and actually saw it work start to finish, going from alerting to the driver to that mechanism. It was very interesting being on the receiving end of it and actually seeing how that affected my driving behavior. And then we have the Haas Alert pilot where we're working on doing a little bit more. But I apologize if I went a little long, but I will pass it over to Matt. And I apologize, Matt, if I didn't leave you enough time. I got a little carried away there.
No, I was just lamenting to one of my coworkers that was listening along that I didn't have dramatic music to play along with mine. So I was very impressed, and that's all very relevant with what we're going to be presenting on, which I think is why Martha got us all together. It's an excellent opportunity to really share the work that USF is doing, University of South Florida. We're supporting this effort. It's a grant program, just like Stephen Parker had talked about in the last session from University of Wisconsin-Madison. This work is the result of a 2023 grant with FHWA, really focused on the real-world efforts that go along with commercial motor vehicle safety and work zones. And the reason why Element was specifically involved in this grant is to look at those opportunities for real-world implementation through design plans, through improving things. So we at Element, we have a couple of different safety contracts around the state. One of them in particular is to review all design plans that come into the Florida Department of Transportation for the Tampa Bay region, District 7 specifically. And so we get to review those. We get to look at all the different lessons learned. And that was one of the reasons why we were involved in this specific partnership between USF and FHWA, was to have that real world discussion about how to get to target zero, how to improve safety in work zones relevant to commercial motor vehicles. And so commercial motor vehicles like motorcycles have a lot of issues with braking, a lot of sudden stopping crashes, and we've talked about that data before, and we're going to continue talking about that data. I have a couple of the why commercial motor vehicle slides here coming up, but that's one thing that we've seen in work zones throughout the state of Florida and then across the country too. And so the whole purpose of this document is to really look at opportunities that we have, tools in the toolbox for designers, so to speak. And we know with all the tools that have been discussed over the past couple of sessions and will be discussed over the next 2 days, is that it's going to take a little bit of everything to get to those, get to the target zero goal, a safe system approach where we really look at those opportunities. And so commercial motor vehicles, like we're talking about, over 10,000 pounds, has braking issues, those kind of things that we want to give alerts, just like Chris was discussing. How far in advance is too far? What can we do to really strategize improving safety for those commercial motor vehicles? And so one of the keys is really having a comprehensive transportation management plan. And so one of the end results of this document, when it's finally published, we're at the very end of the process with FHWA for development, is to have that practical transportation management plan checklist for those designers. Another tool in the toolbox where they can check boxes, make sure that they're not providing a detour route through a local neighborhood that's not prepared for commercial motor vehicles that might be out there, and really talk about all those different stakeholders that could be engaged to really collaborate among different agencies, industries, communities. Also have that enforcement component that we really know has a very strong impact on safety outcomes as well. And so like we've been talking about, we understand the conflicts with CMVs, cars, passenger vehicles, typically misjudge CMV blind spots, the turning space and the stopping distance that are required. So really all of that was taken into consideration as we were developing this document with FHWA and USF and looking at that data. And like I had mentioned, we're really looking at those rear end crashes, really looking at the sudden stopping and the tools in the toolbox for eliminating those types of crashes where we see, hey, 44% of the CMV crashes with the long stopping distances, sudden stops in the work zones. What can we do to eliminate those? What can we do to get alerts, just like Sarah was talking about, in-cab alerts? What's the effectiveness? What alerts can we tie to those specific driver tools that are already in the cab? And so, again, we've talked about the data at length. 71% of the fatalities are occupants of non-CMVs. So we know that this disproportionately affects CMVs, but those crashes are also severe to the other users on the roadway. And really what this document focused on was really having that safe system approach to work zone management and to use the safe system roadway design hierarchy that FHWA has posted. And so we want to remove those severe conflicts. We want to work on reducing vehicle speeds. We want to manage those conflicts in time and increase attentiveness and awareness. And so this is talking about using all those different tools in the toolbox that Chris and Sarah and the others have talked about, and developing a checklist from that. And then looking at those additional factors where we have tapers. Are the tapers developed long enough? Are they designed for the vehicles that you're seeing on that roadway? And if you can't make accommodations for those designs, let's look at different detour options. Let's work with our industry partners to put out awareness, put out notices, to really share that message that we're going to have a roadway under construction that is not suitable for some vehicle types. And let's look at different opportunities to reroute, detour, and make it safe for the users that are going to be using that facility. And so really it comes back to that transportation management plan to have awareness about all the different aspects that you need to be looking at, whether it's local governments, whether it's local shipping groups, industry stakeholders. What can we do to proactively plan to provide that freight efficiency and roadway safety with all our different partners, doing public information and outreach, transportation operations, doing the variable message signs in advance of work zone or significant detours and closures, really considering all of those users that you're going to have. And so again, just highlighting a couple of the different steps for tiers that we identified through this process, removing those conflicts, making sure you have the truck escape ramps if they happen to be in place now, maintain access to those, maintain adequate lane width, all the way to tier 2, reducing vehicle speeds, and then tier 3 was managing conflicts, and then tier 4 was increasing awareness through those real-time alerts, just like Chris was talking about, geofenced alerts, in-cab, all those opportunities. It's really just about utilizing those tools in the toolbox that we have and that are continuing to be developed further, and really facilitating that targeted outreach to all the users that we have. And again, just the enforcement discussion It really impacts the use. That is a big target in our area of Florida. There's a lot of high visibility enforcement efforts. There's a lot of engagement with law enforcement just because of the strong correlation between safety results and the speed. And then we talked about education and collaboration, looking at those different collaborative approach. District 7 here, Tampa Bay in Florida, we've done numerous work zone road safety audits, multi-agency task force to really look at those enforcement efforts as well, and really opportunities to do CMV training and public outreach as well. So we have a lot of different tools in the toolbox that we want to continue to utilize. And so over these last couple of slides here, we're really talking about technology and innovation, engineering and design, agencies and organizations, and then drivers. There's just so many different ways that we can provide additional outreach and support to get these design plans, to get our work zone safe throughout the life of a work zone, from setup to when that last worker leaves the work zone, that this toolbox is just, we wanted to provide a checklist. And so hopefully you'll tune in on Thursday at 4. Dr. Lynn with the University of South Florida is going to give an additional update as part of that session as well. And so you'll see a little bit more behind the scenes about what other upcoming topics we're covering. And so, you know, just as I close here, we're really looking at just all those different safe system approach versions that we can use to enhance safety for our workers, for users throughout, whether you're walking through a work zone, biking, or driving a commercial motor vehicle, just so that everyone gets home safely like we've been talking about throughout the session. And so with that, I think that's my last slide. So we'd love to take any questions that everyone has.
Yeah, thank you all for your presentations. We're open to questions, so feel free to drop any questions you have in the chat.
Is this where we put the crickets GIF in the chat? We'll be monitoring the chat too, so I'll be here for the next session. So I'm happy to have my contact information out there, and we'll be sharing our slides as well.
All right. Thank you guys very, very much. That was a wonderful session. Let's do a little virtual round of applause. That's kind of, you know.
Oh, actually,
Brad
looks like we got
Brad with the
one
question. All right.
What recommendations do you have for owners and contractors that they can implement today to reduce CMV incidents?
I mean, for me to start just from the design perspective, it's really take a look around and say, do you think it's possible to drive a CMV through this work zone, whether it's an articulated truck or a bus? Do you think I can safely do that? Can I safely expect someone to do that in the middle of the night? And if not, what changes can I immediately make? Because it's, whether it's longer taper, sight distance, because it's a different height, whatever it happens to be, really put yourself in the perspective. I'm also a cyclist, and so I do a lot of riding through work zones and through the projects that I'm designing, so that I see from that perspective. So put yourself in the perspective of a CMV driver and really say, is this something we can expect an unfamiliar person to do safely?
I would also say, you know, if there's any way to use what you've got already, and as a human factors person, any opportunity to reduce distractions, the amount of stuff you have around. I mean, you want all of your attention is a finite resource, and you want all of your attention on the road and keeping those other people safe. So I know what I'm proposing is that we give you more messages, but we give you messages on a device you already have in your truck, and that sort of thing. So use the tools you already have. Don't add any more things to look at or any more things to do, if at all possible.
And I would say just making sure that you're taking advantage of some of the existing technology that's out there. Um, just simply one thing that I tell a lot of my the employees across the state of Michigan that are out there inspecting projects is you today can go up and pull up ways and mark yourself as a work zone or mark yourself as a worker with just the app on the phone. Now we're doing a lot more with testing out, the devices and units that automatically do that when our light bar comes on. But that's something that is very simplistic that can be done today at really no cost. It's just a matter of planning that. Closing a work zone or closing a lane down or a ramp down, utilizing a navigational app. When that closure takes place and you're out there in the field and you pull those barricades across, not everyone is going out there and doing that. And that's just something that you can do on Waze for free. And I know there's other ones you can do. I just know Waze is the easiest one to put it in. And then if everyone on the crew likes it, you know, that's just something that's always what I go to for the fast, easy, simple. What can I do tomorrow? What can I do today? You can do that. If you pull over on the side of the road on your way home and you get a flat tire, if you have Waze, you can mark yourself as a hazardous broken down vehicle, and there's a potential for someone to see that to get over. Now, that outreach is not there yet to everybody, but it's only growing as everyone's been talking about. This is only going to exponentially grow. So getting into the habit of doing those little things now will allow you to take advantage of those autonomous devices later on that are going to then just streamline this into something that you're already used to doing.
Perfect. And we have about a minute left and one more question. For Michigan, are there any connection issues in the rural areas?
I will say that in our testing, we didn't necessarily get out to those areas. That wasn't really a focus. I'm assuming that there will be. I know a lot of the different companies and things like that are working on that via different satellite technology and having the location ping off multiple vendors. So, yes, in Michigan, there's still spots where my cell phone doesn't work or my call will drop. As surprising as that sounds to maybe some people, but there are times when we're driving up in northern Michigan or the UP where you just don't have service. And I think that's a problem across the board, but I don't want that minor item to be a hindrance to the masses, because in those areas where you have that rural, your volumes are lower and your likelihood for the crashes and things like that to occur are a little bit less. So it's not necessarily a primary focus area, but I think naturally by the time we get there, just with the way technology is improving, I don't foresee that being a limitation or a major limitation that we can't overcome. It's definitely not something that I don't think we're going to focus on right now. I think there's a lot of other issues to solve as far as just getting that point right and the location right. And as Ross talked about, the information of data, sharing it, ownership, there's a lot to unpack. And I think by the time we get that all unpacked, I'm hopeful that the connection issues will resolve themselves just like how they naturally are. And everyone has pretty good bandwidth now with internet and things like that. So I can only imagine that's going to handle itself. So I think it's a good point, good something to be aware of, but not necessarily something that we have specifically focused on.
Yeah, perfect. Thank you so much. I think we'll close things there and pass it back to you, Matt Moore.
Fantastic. Thank you again, everybody, very, very much. We'll resume in just 4 minutes, so go ahead and get your coffee or whatever it is you need to do, and we'll see you in 4. Thank you. And a reminder, we'll be resuming in just 2 minutes with our speed safety cameras in work zones update. At the conclusion of that, we'll come on for our quick technology showcase. So we're looking forward to all of that. Thank you very much. All right, and we are back with the last session of the day, and things are really heating up with speed safety cameras in work zones. So let's have our moderator, Brad Sant, come on up. Brad, come and join us.
Well, good afternoon, everyone, and thank you for staying to one of the more anticipated sessions of the day on speed safety cameras. You know, we know from a lot of research over the years that law enforcement and active law enforcement is one of the most effective ways to get motorists and other road users to obey posted traffic speeds. And the implementation of speed safety cameras, and that's been really accelerating in the recent years, is one of those proven ways to do that without necessarily putting law enforcement officers in jeopardy and having them parked in dangerous positions related to the work zone. So we're excited to hear some of the latest developments that are happening with our work zone speed safety camera program. We have three great presenters for it with us this afternoon, and I would like to introduce them. We start with Benjamin Asimovic. He serves as the Traffic Operations and Technology Manager in the CDOT Traffic Engineering Services Branch. That's Colorado DOT. He's been with the Colorado DOT for 23 years with experience in roadway design, project delivery, estimates, CMGC, and traffic operations engineering. He leads the speed management and automated speed management program teams working to ensure safer roadways through speed reduction solutions. Joining him is John McGregor with the Indiana DOT, and his diverse experience includes extensive time working in traffic operations at the Indiana Department of Transportation. He worked as a traffic systems engineer, a work zone supervisor, and a signal systems supervisor at the INDOT Traffic Management Center prior to accepting his current position as the Director of Traffic Operations in 2018. In his current position, he's responsible for the work zone section, the Hoosier Helper Program, and the INDOT TMC Call Center. He earned a bachelor degree in construction engineering and management from Purdue University, a finance MBA from Indiana University in Indianapolis, and is a registered professional engineer. Wrapping up our team is Nagam Matout Elzine. She joined the American Traffic Safety Services in January 2021 as the Innovation and Technical Services Manager. She earned her bachelor's and master's degrees in civil engineering at the Concordia University in Montreal, and is currently working on her doctoral studies in civil engineering at Virginia Tech. Her career is focused on roadway safety, including roles at the Quebec Ministry of Transportation and as a consultant supporting FHWA and the DC DOT on projects in safety operations, human factors, and asset management. She also managed FHWA's Workzone Traffic Grant Program, and we were very familiar with Nagan then. She's fluent in English, French, and Arabic. So let's welcome our speed safety camera team, and we'll start with Benjamin.
Hello there. Let me pull up my thing real quick. Yes. Go. There we go. Okay. Welcome. My name is Benjamin Achimovich. I work for Colorado Department of Transportation as the Traffic Operations and Technology Engineer. I do a lot of smart work zones, a lot to do with speed management, and now I'm the program manager for the Colorado Speed Enforcement Program. A couple things we're going to go over. We'll go over the background of our program. We'll go over what we are doing now, and a little bit about our local agency piece as well. Work zone fatalities in Colorado have been going up for the past 3 years. In 2024, they peaked at 31 fatalities in work zones, almost double from 2023. Now we're doing a little better in work zones this year. We're only on track for about 20 to 25 fatalities, but still that's a very high number. And in 2023, this Colorado legislature gave us a green light to start using more tools to make our work zones safer. Right? But in this, we had a need for reducing crashes within work zones, slowing people down to reduce crash severity, improving driver behavior, and enforce adherence to our posted speed limits, and then reduce the travel speeds along what's called our automated vehicle identification system corridors. It's a long legal word for speed safety cameras, but it's the word we got to work with. So really the overall goal here is to reduce speeds and increase safety. Like I said, in 2023, the General Assembly passed a revised statute, 424110.5, so you can go look that up if you'd like. They then revised the statute in 2024, expanding the use of speed safety cameras under the guise of automated vehicle identification systems throughout Colorado. This allows CDOT and local agencies to enforce speed compliance using cameras and sensors in our high-risk driving corridors, which includes work zones. This statute is very definitive. It says exactly what we need to do in almost 95% of the process. Right now, we can deploy speed safety cameras in work zones, school zones, by municipal parks, and in designated AVIS corridors, which we have to pass by resolution or ordinance, or for the state, we have to pass it as either chief engineer justification or a transportation commission resolution, depending on the justification levels. It also allows these AVIS corridors to be designated from, say, milepost 1 to milepost 3 by the following. Local agencies have jurisdiction on all of their local roads. State and U.S. highways we can deploy speed safety cameras there by any of our agencies, whether it's CDOT, Colorado State Patrol, or local agencies with CDOT and CSP approval. And then interstates are the jurisdiction of CSP and CDOT only. It specifically states that in our law. Work zones and school zones, anyone can deploy on any roadway in the state. They don't need to designate it as an AVIS corridor because those are two really critical safety zones as designated by law. We are looking at a possible update to the law to clean up a few more things around speed limits and the fines. I just saw the current revised law, but these laws really evolve over time, especially in the Colorado legislature, with the local agencies so heavily involved. a few things in our law have a gap. For instance, the law says, hey, you have to have 30 days of warning period before you can assess violation penalties. But it doesn't say if that can be extended. It doesn't say if that can go on for months. It's a gap in the law. So we had to look through the law and make sure we had administrative rules that govern the use. It reiterates both the law and it fills in some of the gaps that we have to use. We have a permanent rulemaking process that put together 2 CCR 60127, and that basically had to go through a public hearing. It had to go through 60 days of comment, and then we had to finalize it with the Secretary of State, and that took us through last month, September 2025, when our permanent rules were in place. And those do govern all of the corridors or over the types of roads that CDOT and local agencies have to go through when putting out either work zone or school zones or AVIS corridor speed safety cameras. Before we jumped into putting out an RFP, a request for proposal, or getting proposals in, we looked at what other successful programs have done. We looked here at Connecticut, really great Know the Zone moniker. They had a really good system and pilot that was very successful, and we learned some lessons from them. We also really liked working with Pennsylvania to learn what they did with their work zone safety cameras. We read all their reports, we looked at their RFPs, and we actually took quite a bit from both of those and also Maryland's speed safety camera program to put our program together and finally get a vendor for deployment. We have a Colorado Speed Enforcement Program page that really manages 2 levels. And I'll talk about our speed enforcement more than the locals here, but CDOT deployments, we manage those in our work zones, school zones, and our AVIS corridors. And then we collaborate with local agencies on all of their designated AVIS corridors to make sure they're adhering to state law and not getting into any trouble legally, especially within our right-of-way. Here's our webpage. This will be in the PDF you get, hopefully after this meeting, so you can go there, you can take a look at all of our FAQs, our violations. We're also going to put together a speed map that'll be on here that will show you all the corridors starting about in January. So we've taken the mapping idea from Pennsylvania and we're putting that on here shortly so everyone can see where our active corridors are and then our reports. Reporting is very big in this law, since we have to report annually and report on revenue, number of violations we've issued, and where the revenue is going. Most of that revenue can go to the operational costs, but none of it can go directly from the ticket or the revenue from the ticket to our vendor. It has to come to us first. We have to justify this is how much the operational costs we are using. And then the rest of it, anything above the operating costs, has to go to vulnerable road user projects. And those are specifically defined in the law and specifically defined for CDOT in other legislation and admin rules. Our system is a point-to-point system. A little different. We don't rely, at least for our current more long-term systems, we don't rely on LiDAR. We use pucks in the roadway. The car activates, goes over the puck. The camera activates, takes a picture of the car and the license plate. Then they go over the pucks at a second position, usually more than a third or a quarter mile down the road, and then it takes another picture. Compares the data pulled from those pictures. If the average speed is 10 miles per hour more of the posted speed limit, a civil penalty is issued. If the average is not more than 10 or 10 or more, all the data is deleted. Sort of a funny story. My dad has a friend who was really anti-government and really anti-camera. He went by, slowed down, made an obscene gesture to the camera, and he was so proud of himself. And my dad looked at him and said, "You know they don't keep that data, right?" And he was just besides himself that he did exactly what we wanted him to. So we don't keep any data unless a violation or is detected. And anytime it's dismissed, the data is erased from our system. So we're very cognizant about when we can keep data, what data we can keep, and how long we can keep it. But it's really hard to argue with physics and math. So this system really gives us a, hey, if you're speeding here, you're speeding here. It's hard to say you weren't speeding through that corridor. Here's how it works. We have a 30-day notification period, CDOT webpage at least, but we strongly recommend robust communication campaigns so people everywhere, unless they're living under a rock, know that it's out there. Then we do a 30-day minimum for a warning period where you get, if you speed 10 times, you're going to get one warning, and only one warning. We're not going to issue 10 warnings to that person. We're just going to issue one warning. At the end of the warning period, whether 30 days or more, we issue violations, and those have to be sent out within 30 days of the violation. And then the violations work for, this is very basic. You have 45 days to pay. We'll go through the first one first. 45 days to pay on day 46. You then get a civil assessment. At that point, you lose the ability to dispute or request a hearing. You basically have to pay it. And then if you don't pay it after 30 days, you get a final notice of liability, and we can go to collections if we serve you in person. And then we can go to collections. But that's a very expensive process. We're still going through that. We haven't issued any collections yet. We probably won't till late next year. If you do decide to dispute and request a dismissal, you can get a yes or a no there. If you get a no, we're not going to dismiss it. You then can request a hearing, and our administrative law judge gives you an answer of, nope, you got to pay it, or you get a ruling of dismissal. And at any time anything is dismissed, you get a notification it's dismissed and it goes away. Other than that, you have to pay the civil penalty, and that civil penalty is a non-criminal penalty. No points, nothing on your driver's license. We can't go to criminal court over these penalties at this time. All right, pilot project is code 119. We did a before, during, and after deployment. So we put data collectors out in March. So we got 2 months of systems data for the roadway. We did a public notification on June 6th saying, hey, warnings begin. And then we started warnings last July. We're going to start violations here in January 2026. I can't stress enough how much before and after studies work for civil engineering and traffic engineering, especially when you're trying to show benefit. So what we did was we did a northbound and a southbound trial with these traffic data collectors. And you can see we definitely have a speeding issue. 13% of folks are going 10 or more over the speed limit going northbound. And then about 15% going southbound are going above the speed limit. And this was through 5/12. We've looked at our data through the end of June, and it was actually pretty comparable. All right, so here is through the end of August. There's new graphics on this, and it is basically leveled out. We've had an 85%, we've had about an 85% decline in excessive speeding in the work zone just during the warning period, and our average speed has gone from 64 to 56 miles per hour northbound. And then southbound, again, very similar. We've had about an 80% decline in excessive speeding, and the average speed, which was closer to 60 southbound, is now close to about 54 miles per hour under the speed limit. So just in deploying these and just deploying warnings, we've already seen a decrease in speeds, and that has held steady through this month. So we've had a lot of success thanks to Waze and here and Google reporting, putting out that there are, before every camera, it says very loudly, speed trap ahead. So we actually have a lot of good cooperation with the public, reporting the cameras and keeping speeds down through this 2-mile area. Here is our schedule. We are now in the violations period assessment. We're looking at making sure our system is ready for violations and hearings. We just awarded our hearing officers, which are our administrative law judges. By the end of this month, we'll have a collections and serving process finalized, and then we're going to start looking at pilot projects right after January when we start violations on Co-119. We're looking at I-25 and Vail Pass as early as March and April of 2026. We have a little bit of a local agency thing here. This is just our local agency implementation. All local agencies have to get permission to deploy on our corridors, and they can't deploy on interstates, so we make sure they have all of the information they need on our local agency page, including our procedures and applications, so they can download it and quickly access what they need to do. This just is a review. Unless there's a formal maintenance package, if they put out permanent signs or permanent cameras, they have to have a special use permit. And then we have region and headquarters state traffic engineers have to approve, and then CSP has to approve. And they can't do anything unless a written approval is complete. We've had a couple agencies say, hey, we don't think this applies to us, and every single one has now been challenged in court. And they've had to repay. So we're trying to work with our local agencies. We're trying to help them be successful. Sometimes that's harder than it should be. That's about it. Any questions? Yeah, I can answer that. There are warning signs that is specifically defined in the legislation. It says that we have to have, for any camera, we have to have a sign 300 feet minimum from the camera, each camera. So if we have 3 cameras on the corridor, we have to have 3 signs. And that's for school zones and work zones. And they have to be designated. So those signs have to be start school zone, end school zone, start construction zone, end construction zone signs at the end. So they designated those areas. For AVIS corridors, you have to have a sign 300 feet before the AVIS corridor starts. So if you say milepost 1, it has to be 300 feet before there, and then a sign before each camera in the corridor. So very sign heavy. We've also put out VMS boards. We've also experimented putting out connected speed feedback signs to really get people to really say, hey, we want you to slow down. We don't want to give you a ticket. The other thing is our signs are huge, at least 4-inch writing. They're big signs that are really hard to miss. The effort was done, I believe, by the local agencies back in 2023, but now CDOT's been involved in 2024, and we're involved again in 2026, just because it's a huge impact and cost to us. Do you have any data on the crashes severity since the cameras have been installed? There was a DUI fatality on Co-119 on July 31st, 10 days after. But since then, there hasn't been a severe injury or fatality that's been reported into us. So the question is, do you have to take a photo of each license plate entering and exiting? Yes, we have to take that picture, and the computer system identifies the license plates. Okay. There you go. And no, we don't have any activists. It's been a very popular program. The end.
Thank you so much, Ben. John, you're up next.
Good enough. Good afternoon, everybody. My name's John McGregor. I'm with the Indiana Department of Transportation. And I guess I'm next on the agenda to talk about our worksite speed control system and our pilot program that we are progressing through. So let's see if I can get this to work. Yeah, next slide. Indiana is positioned as a southern Great Lakes state. We are often considered a flyover state, but we move a lot of commerce between Pennsylvania, Ohio, Illinois, Indiana. And we definitely have a speeding problem. Little bit of the inside baseball is our construction lobby worked for 4 years going before the General Assembly. And in 2023, they were able to successfully, barely move into a pilot program, pass legislation. It was bipartisan in that people on both sides of the aisle, the more libertarian people tended not to like it, but the more pragmatic, save a life sorts definitely were interested because, we do have a worker safety and a motorist safety concern. You look around and we only had a couple of programs back then to model off of. The ones that were active were rather small. Those are in green, Illinois, Pennsylvania, Maryland. But others were coming along with their pilot programs. Again, was it an issue in Indiana? Heck yeah. One of our sites we used as a test site. As you can see there in red on the northeast side of Indianapolis, 465 and Interstate 69. We did our own speed testing before we tested any of the systems. And we determined that more than half of the people were in violation of the threshold. The threshold is 56 miles an hour, right? And it's a 45 mile an hour work zone. Our legislation would have us enforce at 11 over. So half the people were exceeding the enforceable range. A good chunk of those that were less than the enforceable were still speeding over the limit. And of course, you have that nice little red line at the top, the people that were just horrible citizens that were being truly dangerous to other people. But we do have a problem with speed in the work zones. So what to do about it? As I mentioned, we passed legislation. It established a 5-year pilot program. Looked a lot like Pennsylvania's and Maryland's. I've often referred to the Indiana program as Pennsylvania's child, Maryland's grandchild. The goals, slow vehicles down, save lives of motorists and workers, and to reduce crashes. The big key to that, slowing vehicles down. How do we do that? Well, we wanted to deter people at the high end, right? So you look at any kind of a bell curve, we wanted to cut the top of it down and move it down, but particularly by getting the people 11 miles an hour over. Normalize the speeds, cut the people speeding excessively. And again, you'll hear us talk about excessive speeding as the enforceable range, 11 miles or more over the limit. That's what we were going after. We wanted less variability. We wanted people to move through, together rather than, the 90 mile an hour driver and my mother that would be driving 45 mile an hour in a 45 zone. That's a recipe for disaster, right? So that's what we're trying to deal with. Our pilot program allowed 4 systems to be in operation. Keys to the system, as I mentioned, again, 11 miles or more over the posted work site. Speed limit's the key. We can't do it anytime. Contractors must be present and signing has to be present. And the legislation simply says signs must advise the motorist. Penalty structure, the first event is a warning, and there is an 18-day grace period after mailing. Essentially, it's 15-day grace plus 3 to allow the post office to do its job. We wanted people to get the notice and understand it. Then after that, as I've often referred to it, you're in the game. I didn't put it in the presentation, but I'll mention that we went live in, I think, what Ben called the warning phase, what we called the pre-enforcement phase, in August of 24, so August 14th to be exact. And we maintained that all the way through the winter. It was May that we went live and the penalty started to be assessed. I just checked the system before beginning, and we're at $563,000 and change in revenue right now. As it says there, Indiana's program, every state has different legislation. We're only able to take the rear of the vehicle. We didn't want a picture going home and, somebody opens an envelope to a spouse and they, who's that in the car with you, stuff like that. We were very concerned about privacy, but it's created the other issue of, well, I wasn't driving, right? Harder to prove that, but we'll get to that in a second. But one of the big takeaways is largely commercial vehicles are exempted because often the trailer is not owned by the driver. Important to note that the revenue goes to the general fund. We did not want either ISP, that's the Indiana State Police, or INDOT, Indiana Department of Transportation, being incentivized. So it goes to the general fund. Now, obviously, a portion of that money finds its way back to all of those agencies, but there is no direct reimbursement. What does that mean? That means that INDOT is footing the bill for this, and we're giving up something for it. This program is worth about $3 million a year. That means that some signals aren't getting built, maybe a roundabout isn't getting built, certainly bridge deck overlays, multiple stuff on that order of magnitude. We've got INDOT operators. Our program requires INDOT to operate the system. And as mentioned there, they've got quite a job. I've got a team of 7 people that are planning, delivering, and operating the camera systems to an extent. We have a vendor on site continuously running them, but we do the startup and shutdown. Our team does the violation review. So we do not have Indiana State Police looking at it. It's our team that provides an affidavit, and we serve as expert witnesses as well. And much like Ben said, administrative law court, we're very lucky. I know some states that do this, they have to adjudicate these locally. Completely glad to have it through OALP, is what we call it. And that is pretty much co-located in central office downtown to the INDOT facility. And just like we're meeting now, it's how the adjudication occurs. Going back to the operators, this is kind of unique to the program in Indiana. As I mentioned, we have to operate it, and what we've construed is that we supervise the startup and shut down, but we allow the vendor to maintain through the day. But we ensure that the startup and shutdown sequences of our speed cameras are operating properly. I don't go into it in great length in this presentation, so I'll mention we are using a LiDAR system. Love the point-to-point. That's great. The LiDAR, I don't think there's much arguing, if as long as it certifies that the speed you're taking is correct. But I think the point-to-point gives greater certainty that throughout a work zone there was continuous speeding. But at any rate, we know when we've got them, we've got them. This is just the basic requirement, as I mentioned. Signing is required. That's all the legislation says. So signing, or signs, I think is what it says, plural. That's required. When we deploy, we provide an active sign. The required signs with the penalty structure on construction projects are installed by the contractor, but we also have roll-up signs for ad hoc deployments. To date, we have not done any of those ad hoc deployments, but that is an option. But the active sign, obviously, if you're putting it out there, it is only on a stand, and our vendor does deploy that when we deploy them to the site. This is an example of one of the large panel signs. This is on I-69 southbound into Indianapolis. To my knowledge, it was the first in the nation to use an overhead structure for a panel sign mount. So we had a lot of fun with that. It was just an opportunity in an urban work site to do that. And again, there's the active imagery. Okay, time for a bit of a pause. So as I wrote there, I'm just going to read verbatim. Many of the images shared were authorized to be shared in this presentation, by Purdue JTRP. Purdue Joint Transportation Research Program is the research wing of INDOT, so that's where our research money goes. And I'll just say that I'm blessed to have them. I really appreciate that team. So these shout outs, 1, 2, 3, show 1, the enforcement vehicle. It is enforcing on the other side of the barrier wall. Cars driving away, like I mentioned, you only get the rear of the truck. Shout out 2 is the placement of the of the active sign, and 3 is one of the advanced warning signs. But the truck itself, we stipulated just a white, not Ram, but this is a Ram, a white pickup truck. We didn't want them looking any different. We tried not to be too cagey about this, try to be candid with people, but in all honesty, we can say, you see a white pickup truck? Yeah, that could be an enforcement vehicle, right? Part of what Purdue has done, and there's a pooled fund study that a lot of the states that have joined us are in, they are looking at the data, the speed data coming in, and they produce these time-space diagrams. So along the x-axis, you have days and parts of days, I think 2 or 3 hours per notch. And on the y-axis vertical, you've got 2 of them. You've got an outer loop and an inner loop. In this case, this is 465 around Indianapolis. But it's a pretty good indicator once you understand time and space to tell you how the mobility is working, right? So red bad, green good, pretty basic. Now I'm gonna have a little fun with this group and say that we're gonna have some fun with the space-time continuum by the end, and maybe I will transcend it at the end of this discussion. Again, more just hats off again to Purdue and my thanks. This is another way they look at data. They provide some hard braking indication. So if you see, the big towers of hard braking, day after day after day, might be good to look at what's going on there in a work zone or just operationally. So again, this is just to tee up to the next slide. So the help that we have with this program, I think really it's the main reason I was invited today, is to talk about what Purdue has done. This is what they're already doing, right? They're getting connected vehicle data from various sources, and they're already analyzing it. This next part where they're looking at our deployment log, it's really very basic. They look at our deployment log, they look at where the signs were, and then they can make some pretty interesting conclusions with it, right? So this is one of those conclusions. Well, what's this? What this is again, we've got mile markers on the x-axis and the percentage on the y, right? So the green are the motorists as they go through a work zone. In this case, we are going from left to right, that are compliant with the speed limit. The yellow is the speed tolerance, right? So that's that 11-mile over range. And what you see here, and they've got these numbered backwards, but if you hit the 1, that's where your first warning sign is, right? And I'll mention the orange. You see that right above the 100%. The orange is the area of the work zone. So people are driving already through the work zone. They're around mile marker, little past 95. They're cruising in, and they haven't slowed down. They see that first sign. They're starting to think about it, right? A little bit more green and a lot less red. Again, the second sign, then they start to react. And by the time they see the active, they really mean it. And as you can see there, once you pass that active sign, the Roman numeral 3, then you get the greatest speed compliance. And look at it. As you go through, you're already past a little past 100 by the time you're active. The active sign, you're around 101.5 where the vehicle is. You've got a lot of people there maintaining a lot better speed all the way through the work zone. And then again, that light colored orange at the top when the work zone ends, boom, they're right back on it. So what this tells us is they weren't respecting the work zone. They saw the signing, they certainly saw the active, and then bang, they maintained it through the work zone, but they were at least cagey enough to know, okay, work zone over, we're going to go back to our chicanery of speeding through, the Indiana highways. We have seen, and it's a very limited set, on average 70% reduction of excessive speeders. Now that's not a 70% reduction in speed. That's a percentage of a percentage, right? So if before you had the automated enforcement, you had 60% of the people driving 11 miles an hour or more over the speed limit. And then when enforcement was there, you had 30%. That would be a 50% reduction, right? But we're seeing on average 70% of the percentage of a percentage reduction, which is to us really exciting. This is a lot to look at here. Again, if you see the lines, you've got, this is a totally different graph. These are the percentage of the people compliant. Or the other way to look at it, speed compliance, you look at the percentage at or 11 miles an hour or more. So the blue line is the first sign, the pink is the second, and the black line is the unit, is the enforcement unit. So as they approach, you've got a high level of people, I'm going to say 80%, that is not compliant across all these days at this particular location. Then they get to the second sign, I'm going to guess that's around, on balance, 55%. And then you get to the unit, you're probably down to about 20%. It's still more than we would like, but it's a radical change. Now notice something else. You've got all those vertical colors, right? The pink, the tan, light green, I'll call it a lavender, a light blue, and a pink. These are changes in where we put the unit inside the work zone. And what we notice, if you're going through the work zone, generally the earlier you get the unit out there, the better compliance you get. But that didn't prove out absolutely consistent either. I think the other part of the story is consistency, right? Because if you look at the end, I'm talking the end around December, so on the right where the green is, that was closer to the beginning of the work zone, but we weren't consistent. We had a lot of days where we weren't enforcing because where there's no color, those were non-enforcement days. And clearly that shows out that when we weren't there, you had a lot less compliance, right? But it wasn't total. Again, I probably put this out of sequence because I talked about the 70 before, but again, these are the cases we looked at and we tried to normalize it to a 5-day week and averaged it out. Again, 70% reduction. But this we're getting into the space and time. So everything I've talked about so far, the whole 70%, and the other data we showed was at the point they're taking it. But this is showing that throughout the work zone, people are compliant. So, and we knew that already because we looked at it, in the chart that had the red, yellow, and green, that once they were told, they maintained. But this showed that they maintained it significantly through the work zone. The percentage of speeds over the speed limit, still pretty high, but way down. Over the tolerance, it was a whole lot less. And again, I'll say it again, that wasn't just at the unit, but that was throughout the job site. So that was very exciting. So that's space. As far as time goes, we did not, for this study at least, and we have done some nighttime deployments now, but we did not deploy at night for the time period this data is considered. And even then, we found a 34% reduction in the speeders going by 11 miles an hour or more between 6 a.m. and 6 p.m. And I miswrote that, excuse me. That should have been 6 p.m. and 6 a.m. Same thing here, results for commercial vehicles. No, I'm sorry, I'm thinking too quickly. That is correct, the 6 a.m. to 6 p.m. But for commercial vehicles, 41%. That really surprised us because what I mentioned before, the secret of this program is that we're not doing commercial vehicle enforcement. And to have a 40% reduction with commercial vehicles, that was pretty exciting as well. I'll mention that we do have a website, safezonesin.com. Again, the cagiest thing we do in this program is we talk about a white pickup truck being an enforcement vehicle, but we are notifying the public of where we're going in advance, and there's quite a bit of information about this program. And with that, hopefully I stayed sometime within the time limit. Again, special thanks to my friends at Purdue, Dr. Jiraj Desai, Dr. Raul Sakari, and Dr. Darcy Bullock. All of those gentlemen have been great support to me and this program, and I do thank them. With that, next speaker.
Thanks so much, John. Nagam, you're up. Oh, Nagam, you may be muted. We're not hearing you.
Better.
Oh, there we got you.
Hello?
Yeah, we can hear you now.
Can you hear me?
We can hear you now.
Yeah, we can hear
perfect. I'm like, great. I am standing between them and the end of day one for the conference, and here I am having technical issues. Sorry, guys, about my technical difficulties here. So let me share. I'm pulling up my screen here. Alrighty. So, good afternoon, everybody. Thanks for having me, Brad and Martha. I'd like to start by first saying that I'm thrilled to be part of this session, especially that both of our first presenters actually, were a great segue of what I will be talking about. So if I had to pick the most frequently mentioned word or sentence during both presentation, it would undoubtedly be speed safety cameras and followed closely by legislation, which is exactly what, my presentation will focus on. So, if, again, as Brad mentioned earlier, speed safety cameras are, deployment of speed safety cameras and legislation are on the rise. So, what if your state, doesn't have a program currently? How can you learn more from others and explore what's possible when, well, one powerful way to do that is by tracking legislation. And today, I'll walk you through a new initiative that ATSA has, our government relation folks developed, which is the ATSA State Policy Map. And it is an online resource that's available to everyone. It's free. You can just go online and you can have access to it. And while the map covers a wide range of roadway safety topics, I'll be focusing specifically on speed safety camera legislation and work zones. So what is the ATSA State Policy Map? Well, it is an interactive map that was designed to help the users to stay informed about policy changes that impact roadway safety infrastructure. That being said, including legislation around speed safety cameras and work zones. So it is an interactive tool, and you're able to filter by state or by a specific topic or issue. And you can also view the bill status and also have access to the proposed legislative text. So what's really helpful about this tool is that the map is actually updated daily. So you are always seeing the most current information that's, out there. So one thing that I have learned during my time with ATSA is the power of understanding legislation, particularly for engineers. So as both Benjamin and John highlighted, in their presentations, the details of the speed safety camera program are often embedded directly in the, most of it, right, are embedded directly in the legislative text itself once it becomes law. So when it comes to speed safety cameras, for example, there are states at different stages. Some are implementing it, some are, exploring it, and others are simply just opting out of it. And all of that could be, you could educate yourself about it or learn more about it through this tool that I'll be covering. So by tracking legislation, states can actually learn from each other's successes and challenges. So having access to this kind of information supports, right, for those that are considering to maybe tried to include it into their legislation, or propose it rather, it supports informed decision making, and it helps agencies and advocates understand the broader landscape. So now I'm going to switch over to our website for a quick live demo of the map. So if you'd like to follow along, feel free to scan the QR code on the slide, or just I also have the link shown on the slide here. I'll take you directly to the interactive map. So this way you can also explore it and follow along if you want. So let me pull up the map here. So when you click on that QR code or enter the link here, you'll see this is the interactive map that you'll see. And what we did, especially for this, we actually made the special request to include a new filter that was the Workzone speed cameras. So if you click on Workzone speed cameras, what you will see is you'll see a list of all of the bills that for different states, and you can see also on the map here it shows the different states that have proposed legislation that are specific to speed safety cameras in work zones. So I'm gonna go over just a couple of real world examples just to show how this tool works. So for simplicity, I'll be looking at the Arizona bill here, which is Senate Bill 1146. So you simply just click on this arrow here, and then it will show you, a summary of what the bill is. It gives you the bill, the title, the status, the last date that the action was done, and then it also gives you a summary of what the proposed legislation was. And then you can also click here to view the full, it brings you directly to the bill text. So why is this important, or what do I learn from this? Well, actually, again, based on what the previous presenter said, most of what you will see, or the majority of what you will see in a speed safety camera in Workzone's program will be mentioned in the legislative text. So for instance, in this one, they talked about the different type of the technology that could be used. In this case, they specifically asked for camera-based systems. They also mentioned that citations have to be issued only once they are reviewed by local law enforcement. So the images have to be reviewed by local law enforcement. And it also mentioned that it needs to be, it can be deployed, speed safety cameras can be deployed in construction zones along other places where speeding is a concern. So the other example is the one here from California, and this one is California. This bill is 289. Again, you see the same information. This one, on the other hand, it passed the second chamber, and it was just recent. So again, in this one, they actually go into more details. They provide details about where the revenue should go to, and that's something that, Benjamin mentioned how they're actually doing it. But again, this is where we have this language, included. It also goes into, when you go and click on the full bill text, you'll see that they even limit the number of deployments up to, they mentioned that up to 125 automated speed enforcement systems have to be included. And they also mentioned that, the system needs to be a camera-based system. So in summary, this kind of legislative detail gives us insights into how states are structuring their programs. So this brings my presentation to an end. I told you guys it's going to be brief, but worth of your time. Brad, take it away.
Well, thank you everyone for joining us and for this very informative session. It looks like we got some fun stuff to play with on the ATSA site, so thanks for sharing that. For all you folks as well, I'll ask Matt to put up our slide at the beginning that we used at the beginning of the presentation. There is a lot of information on speed safety cameras on the National Workzone Safety Information Clearinghouse with links. I've also placed that into the chat. So you can find those links there. And again, thank you to everyone who has presented here. Again, we apologize on behalf of the folks at the Federal Highway Administration who really do want to be with us and put a lot of work into this. And again, they expressed their desire to participate, but because of circumstances cannot. But we thank them again for all their help. As we wrap up today, I invite you to stay tuned. We'll show some technology videos at the end, certain companies that have worked on technologies to improve work zone safety, and there's the QR code to find those. And also invite you back tomorrow afternoon. We'll be getting in at 12:30 with a session on data. And tomorrow's focus is more on kind of the worker safety side of the program, while we focus today more on the traffic side, but really good information for everyone, talking about the types of hazards that are hurting us, and how to deal with liabilities and prevent insurance and claims in that regard. Also on partnerships, successful partnerships where groups have worked together to public, private sector, industry to promote work zone safety. So a lot of great information tomorrow. Join us back then, and stay tuned for our technology showcase. Again, thank you so much for joining us.
Every single state right now across the United States that utilizes e-ticketing has the capability to automatically broadcast worker presence notifications to the traveling public. At its core, digital construction material data provides agencies with actionable information that a job site will have construction work taking place somewhere in their state or region. And a growing number of states, 11 in total, are exploring how to combine every single technology-capable device on the job site and turn that into a safety feed. The goal is to make real-time, accurate, actionable, and redundant notifications to the traveling public about worker presence, regardless of what technology is used, reducing that barrier of entry to zero. In 2022, the Delaware Department of Transportation approached us with that very hard question: what else can be done with e-ticketing data to protect our workers? This came after a motorist unfortunately died on the construction job site, and we've been on this road ever since. And this question has been asked for every single new addition to the eDoc platform. And now, with 30 plus states already utilizing e-ticketing in some shape or form, we can start broadcasting that information to the traveling public right now. Protecting workers is our mission at Haul Up. It's something that we dedicate every waking moment to. Every construction job site should be safe, and every worker, private or public, should be able to go home healthy at the end of their shift. And nothing will stop us from achieving that goal. And to accomplish this, we partner with construction equipment companies, device manufacturers, safety vendors, and a significant number of state departments of transportation, from California to Maine and from Washington to South Carolina, to work to improve these safety outcomes. Our idea is straightforward and simple. We must do better at taking the things that are already readily available and already in place right now to protect these workers.
At Trimble, we offer a new and safer workflow for managing payment and roadway assets. One of the safest and most efficient ways to collect data is with the Trimble mobile mapping system. The system involves two lasers collecting millions of points per second, panoramic and dedicated pavement camera, and embedded Trimble Genus SINS system to ensure sub-centimeter accuracy. An operator stays in the car while the system collects information about transportation assets at highway speeds. There is no need for an employee to be on an active highway and no need to drive slower than surrounding traffic. Once the data is collected, it can be analyzed in Trimble Business Center, also known as TBC, Office Software. AI-powered tools automatically extract information about pavement distresses according to standards used by owners. In addition to that, using the very same dataset, TBC can automatically extract information about all the other roadway assets, including guardrail, poles, traffic signs, and more.
Hi, I'm standing here on the side of Interstate 5 in Glenn County, California, with traffic zooming by me at 85 miles an hour. And the technology that we are now starting to utilize is mobile terrestrial LiDAR scanning. More specifically, some of the new tools that Trimble has developed with automated feature extraction and classification for roadway surfaces, specifically pavement inspection. So traditionally, if we were doing a pavement overlay on a road like this, I would have inspectors wandering along the side of the highway. They would have a clipboard, they might have a measuring wheel, and they would have upside down paint, and they would be marking out dig out locations. Again, not a super efficient process, highly dangerous. As you can see, I have 80,000 pound trucks driving by me at 70 miles an hour. Not the best environment to be working in. So if we can do this more effectively with some of these new tools at highway speed at 55, 60 miles an hour, with the mobile scanning system, number one, we can be a lot more efficient, but number two, we can actually be a lot more accurate.
Hi, my name is Tom Parbs, and I'm the Vice President at HozAlert. The technology that I'm highlighting today is Safety Cloud by HozAlert. This life-saving safety service gives advance warning via notifications to motorists 30 seconds upstream through their phones, through their infotainment systems, natively through popular auto brands, or via leading navigation apps. This prompts motorists to actually slow down and move over before they get to our road crews. The Safety Cloud technology is currently deployed across thousands and thousands of agencies in the US and Canada, and even more in the UK, Europe, Australia, and New Zealand. It has been proven to reduce the risk of near miss, collision, injury, or death by as much as 90%. Further, it's been shown to reduce hard-braking incidents that lead to intrusions, lead to collisions, lead to injury or death by as much as 80% or more. And recent independent studies have also shown that 97% of motorists slow down and move over within seconds of receiving the Safety Cloud alerts. If I had one desire for the industry, is that everybody goes home safer to their family every day. No more injury, no more death.
Removing tape is one of the most dangerous tasks in a work zone. Workers are often on their hands and knees,
sometimes using grinders, inches away from moving traffic. Our new tape technology enables the automation of the work zone. Now, a single worker with a cart and a tape peeling machine can remove the marking tape in one pass. That's a real game changer. The work is faster, which means less time on the road, which means less worker exposure in high-risk areas. Also, since workers don't need grinders or water blasters, there's no scarring or ghost lines on the pavement that can cause long-term hazards for drivers. Our all-weather removable tape technology has been used in projects spanning 29 states across the United States. On a high-traffic bridge deck in Miami, where other tapes had failed, our tape remained in place and removed in one piece after 7.5 months of extremely high ADT. Michigan has also been a leader in adopting this high tensile strength tape and has completed several successful projects that underscores its effectiveness. 3M Pavement Marking's mission is to help bring families home safely, and we believe that our 710IR series tape helps us achieve that goal by helping improve the safety of roads and work zones. Now, 3M Stay Mark temporary pavement marking tape can be used as part of an efficient, automated removal system that helps reduce the time workers are on the roads. We believe this can help save lives.